Hello, am I audible?
Yes, sir. Yes,
Good
sir.
morning, sir.
Good morning, good morning. Just 2 minutes, you please wait. Participants are joining rapidly.
Okay, sir, no problem.
ಅವ್ರು ಪಾಪ ಚಳಿಗಿಳಿದ ಎಲ್ಲರೂ ಏನು ಮಾಡ್ತೀವಿ.
What? 19%.
Start ಮಾಡೋಣ ಈಗ. Now we
Yes,
are
sir.
going to start, just do some introduction.
Good morning, sir.
Good morning, sir. Namaste.
Namaste, sir. Sir, welcome you for this 5 days Atal sponsored FDP organized by Department of E&C PDCEG Kalburgi. So now I'm going to give a brief introduction of today's speaker, Dr. Santosh R. Desai, sir. Sir, presently working as a professor in the Department of Electronics and Instrumentation Engineering, BMS College of Engineering, Bengaluru. Sir has obtained diploma in electrical engineering from KH Kapoor Institute of Technology, Dharwad in the year 1994. Then Sir has joined the BE Basaveshwara Engineering College, Bagalkot, and obtained his BE degree in Electrical and Electronics Engineering from Karnataka University in the year 1998. Later, Sir has joined MTech in Power Electronics Vishwesvaraya Technological University and was awarded with his PhD degree by Indian Institute of Technology, Roorkee in the year 2014. Then Sir has started his career as a lecturer in the Department of Electronics and Instrumentation Technology, BMS College of Engineering from the year 1998, and Sir presently working as a professor in the Department of Electronics and Instrumentation Engineering, BMS College of Engineering, Bengaluru. Sir was the Chief Coordinator Evaluation, BMS College of Engineering during 2013 and 14, and currently he is the member of Department Academic Committee and Department Purchase Committee. He is also a member in the Board of Examination for Electrical Science Cluster under the Autonomous Scheme, BMS College of Engineering, and he is a NBA coordinator for the Department of Electronics and Instrumentation Engineering. He has the several publications in leading journals apart from national and international conferences. He has ongoing and completed projects grants worth of 70 lakhs. So now I welcome you, sir, for presenting the session on introduction to the machine learning. So now I will hand over the session to the Dr. Santosh Desai, sir, to present the participants.
Yeah. Thank you very much for giving an opportunity to share the information, whatever I have gathered so far in my past several years of experience. So I think this is your fourth day of your participation in this 5-day FDP. I think by this time you have gained some kind of a glimpse of what is this FDP all about and what are the various concepts that comes into picture when we talk about artificial intelligence. So one of the parameter or one of the main concept that comes into picture when we talk about artificial intelligence is machine learning. So I thought let me share some of the experiences or the knowledge that I have gained so far so that it may be helpful for you to carry forward your research, or if you want to do some projects, or if you want to communicate in turn to your students or to your juniors, so that you can do at your leisure time. However, we will not stick to any particular software right now. So it is an open challenge for you to browse various softwares and check out which software you would like to use, whether it is MATLAB or Scilab, or whether you want to make use of R programming, so on and so forth. So now, not wasting much of the time, I would like to go to the slides. I think the slides is visible to you, right?
Yes, sir.
Yes, sir.
Okay. Okay. So the contents of my slides will be something like this. I will be having, I'm going to discuss about the machine learning, what has happened in the field of machine learning so far. What is this machine learning comprises of, how to define the machine learning, what are the definitions. So if you refer to different literatures, of course, they define in their own way what is machine learning. So also we will also highlight briefly why this machine learning has gained so much of prominence right now in the market right now, whether it is industry or whether it is academia, how machine learning is being used widely in the today's environment. So that is one thing. And apart from that, we will dive into a little bit lightly into what are the different types of learning we have right now. We will restrict ourselves to only 3 types of learning, and also at the before ending this session, I would like to have a glance over what is this machine learning cycle, program cycle, or the process comprises of, what are the various stages it is going to comprise of. So with this, I'm going to end my session, and this particular session is being formulated or is being designed in tandem with another session that is coming up the after my session, that is at around maybe 11:30 or 11:45. So once again, Mr. Shankru is going to take up this particular session, and he will be able to share much more information, and he will be giving you an insight of the different types of learning and how these learnings can be adopted in order to accomplish various tasks that comes into picture that we usually encounter in our day-to-day lives. So this is our brief overall structure of my presentation for today's session. So when we talk about machine learning, the word comprises of two different, the machine learning, the whole phrase comprises of two different words, machine as well as learning. So in order to, if you dig back, we have to go back in the late 1950s, wherein Alan Turing, he mentioned in his paper the titled Computing Machinery and Intelligence, and he asked whether he describes there whether machines can think, whether machines can think actually the way the humans can do so. So this paper he describes as imitation game, which involves basically three participants, human acting as a judge, another human, and computer that is attempting to convince the judge that is a human. The judge would type into the terminal program to talk to the other two participants. Both the human and the computer would respond, and the judge would decide which response came from the computer. So if the judge couldn't tell the difference between the human and the computer response, then we say that the computer has won the game. So the overall gist is that the judge who is sitting, he should be able to differentiate between the communication that is being made by the computer as well as the communication made by the human. So if he is not able to recognize, then it's a win situation for the system itself. So this is how the artificial intelligence came into picture, and the test continues still today in the form of a Loebner Prize. This is just for an information, and an annual competition in artificial intelligence is being held as well. So in the late 1950s, once again we have the Samuel's check player algorithm, wherein he mentioned about that the machine learning as a field of study that gives the computer ability to learn within the without being explicitly programmed. So his focus was on the games as a way of getting the computers to learn things. The game of choice for Samuel was checkers, because it is a simple game but requires strategy from which the program could learn. So Samuel is basically widely known for his work in the field of AI, that is artificial intelligence. But he was also noted for being one of the first programmer to use hash tables, and he was a well-known personnel in IBM. His checkers program learned to improve its playing by itself. A computer can be programmed so that it can learn to play better than the person who has programmed to play. So basically, in his paper, or if you go through the literature, it is said that three factors comes into picture when we talk about Samuel. So the data that is consumed by the program, a metric which quantifies the error or some form of difference between the current behavior as well as the actual behavior, or sometimes it is also called as the ideal behavior. So that is the second term, and the third term is the feedback mechanism, which that uses the quantified error to guide the program to produce better behavior in the subsequent events. So this is a brief overview that is happened in 1950 apart from Selbridge pandemonium, and in 1960s came I mean was I mean neural networks pattern recognition started coming up in the after a decade back, that is in 1960s. In 70s, symbolic concept induction, Winston Arch learner, and Macaulay's AQ and solvent diagnosis came into picture, and in 80s, advanced decision tree as well as rule learning, EEPL, utility problem, and then cognitive architectures. In 1990s, we had started with data mining, adaptive software agents, web applications, reinforcement learning, ILP. In 2000, it saw an eruption of SVMs and kernel methods, transfer learning, sequence labeling, and in 2010 we had deep learning systems learning for big data. As you might have seen everywhere, it's an era of IoT right now. When we talk about IoT, big data comes into picture because we connect all the devices are connected with some or the other kind of sensors, so they generate huge amount of data in terms of paratypes. So all these things are just an information to you, so that it should be made clear what is the how this machine learning is linked when you dig back. So as I said in the earlier session, that the phrase machine learning comprises of two different words, machine as well as learning. So somehow I thought of defining these two words separately. So as per Herbert, so learning is any process by which a system improves performance from experience. That is how learning is being defined. Machine, as usual, you might have heard, there is this, there was, you say, in one of the a very well-known film, Three Idiots. So the professor would ask the person, "What do you mean by a machine? How do you define a machine?" So, machine is a device that having a unique properties, or that augments or replaces human or animal effort for the accomplishment of physical tasks. So, this is one of the definition. Now, after going through the definition of machine as well as learning, how do you define machine learning? That's the question. So when we talk about definition of machine learning, one person that comes into picture, who is the chair of machine learning at Carnegie Mellon University. So he is also authored a book which is being published by McGraw-Hill, maybe 1995 or around 98 or 99. So according to him, he defined the machine learning basically a computer program that is set to learn from experience E. So you can notice here on this particular slide that, yeah, so is basically machine learning is the study of algorithms that comprises of these parameters, the performance, the task that needs to be accomplished along with the experience E. So computer program is set to learn from experience E with respect to some class of tasks and performance measure P. And if its performance at tasks in T as measured by P improves with the experience E. So the important thing here is that you have a set of objects to define machine learning, and these objects are nothing but the task T. Either depending upon the complexity of the problem, there may be one or more tasks that needs to be accomplished, and we have the experience. and also the performance will come into picture. So with a computer running set of tasks, the experience should be leading to increase the performance. So now coming back, what is this machine learning? How do you define? So the term machine learning was basically coined by Arthur Samuel in 1955, 1959, as just now shared to you. So he defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. So apart from that, we have different definitions from various sources. One of the sources is that the machine learning refers to a system capable of autonomous acquisition and integration of knowledge. Another one is that is what I had just now quoted. This is being quoted by Arthur Samuel in 1959. So now machine learning has gained momentum in the past several years. When I show this particular slide to you, it is quite clear to you, and you feel that you might have seen such kind of slides. You might have seen a slide wherein there is some relation between artificial intelligence, that is the core of this particular FDP, and it is being associated with various terms such as data science, big data, deep learning, and machine learning. So this particular slide uh, will give an glimpse of where exactly this machine learning is going to lie when we talk about all these concepts. So as you have already noticed that by this time that machine learning has gained momentum in the past several years due to huge success that have been made in the various fields such as object or speech recognition, autonomous systems. Now we were talking about driverless car, automatic machine translation, image caption generation, so and so forth. So along with the wide variety of origins, the field also finds application even in industries as well. Whenever we talk about object or voice recognition, it has got wide application in industries for under various situations. So what I want to bring to your notice is that machine learning is basically an interdisciplinary area of research based on the statistics, probability, neuroscience, physiology, and sometimes physics as well. So machine learning is a mathematical formalization of learning, and as such, there is a discrepancy between natural learning as humans and animals, which is a basically biochemical process, and learning on computers, which is a mathematical abstraction. So when we talk about human learning, it's basically carried on in wetware, whereabout, however, when we talk about computers, such kind of learning happens in in a digital hardware. So ML, if you look at this particular diagram, the ML is a significant subtopic within the parent field of this artificial intelligence. That is what you have seen. And this Venn diagram highlights the how the ML is being related to DL, AI, as well as the big data. So now, uh, now we have already spoken to some extent about machine learning. Now, what do you mean by artificial intelligence? So, according to Alan Turing, artificial intelligence is being defined something like this. Suppose if there is a machine behind a curtain, assume that there is a room, and there is a curtain, of course, and behind the curtain there is a machine, and you are going to interact this particular machine by using by using some means, either audio or by typing or giving an instruction, whatever it is. And if the human feels like he is interacting with another human, then the machine is we say that it is artificially intelligent. So this is quite a unique way to define artificial intelligence. As per modern perspective, whenever we speak about AI, we mean that machines are capable of performing one or more tasks, understanding human languages, performing mechanical tasks involving complex maneuvering, problem solving involving large data in very short time, and answering the questions just the way the humans do usually. So this is what is all about artificial intelligence. Now, when we talk about big data, where this big data comes in. So already, as I said earlier in the initial slides, I had coined a word called as IoT or IoT. So whenever you speak of IoT, big data is generally associated because we talk about so many sensors connected to various devices, and these sensors will be generating data continuously. So this will result to what is called as big data. So now big data processing has become a very interesting and exciting field nowadays. And since the advance of cloud computing, it has got more momentum, and it is being this particular phrase is being quite in almost or every nook and corner of the industry. So why the name big data? Generally, sorry for the interruption. Yeah. So generally, when the size of the data is large enough such that it cannot be processed on a single machine, then such a type of data we refer to as a big data. And generally it equates to around 10 GB or more. From there it can go to hundreds of petabytes. So this is what big data is all about, and it should be made it is seen from the picture that ML is an important portion of AI, as well as it is an important portion of AI as well as deep learning. In terms of current interest and development, actually the figure should be inverted. The deep learning has started gaining more attention as compared to the machine learning as well as AI. This is in general I'm speaking about. So now, where are these machine learning are being used? Where these machine learning's algorithms or concepts are being used? So it is being widely used in various sectors such as software, stock trading, robotics, advertising, retail and e-commerce, gaming, and analytics. So when we talk about software, we have two aspects over here when we dive into this particular aspect. So in software, we have one of the major uh, challenges that we generally face is that the spam detection. When we go to your emails every day, you receive around a good number of emails. How to differentiate between the mails that is considered to be as a spam and the mails which are really important to you, which are really useful to you? So machine learning is widely used in this software to enable an improved experience with the user. So spam detection is one of the classic uses of machine learning, and over time the algorithm has got better and better responses, and it is doing well. So another thing that is coming up is voice recognition. So nowadays you might have heard about various voice assistants that are made available to you, whether it is Google Assistant, Siri, or Alexa. So Siri is one of the example of which is an example of machine learning, and it works out when you want to do and it works out what you want to do. The result might be sending a tweet message, or sending an SMS, or whatever it is. It could be setting a calendar appointment as well. So these are some of the examples I can cite when we talk about machine learning in software. Similarly, when we talk about stock trading, so what is this stock trading comprises of? Right now, you are already aware of what is this stock trading all about. So there are a lot of platforms that aim to help users and make better stock trades. So which particular stock I need to invest today, and how much amount needs to be invested. And if there is somebody who can assist me in order to guide me, okay, this particular company's stock is going to increase, or this company's particular stock rates are going to decrease this way, and if you want to improve your revenues, if you want to land in profits, if there is somebody to guide me, then that would be more helpful for the persons who buy or sell stocks. So this is how machine learning can be made use of. That is one thing. And another one is another important field that is coming up, or it is gaining of more important interest, is robotics. So usually robotics using machine learning can acquire skills or can learn to adapt to the environment in which they are being deputed, they are working. Robots can acquire skills such as object placement, grasping the objects, locomotion skills through either automated learning or learning via human intervention. And with the increasing number of sensors within the robotics, other algorithms could also be employed outside of the robotics for further analysis. So this is how you can deploy a robo in any environments, and the robots will be programmed, or it can be able to sustain the environment and adapt to the changes that it comes across. So another field that is coming up is how machine learning is will be helpful in when we talk about advertising. So for as long as products have been manufactured and services have been offered, companies have been trying to influence people to buy their products. So this is another important task that comes into picture. So since the penetration of the internet, the marketeers have the chance to advertise directly to the customers without needing any television or large print campaigns. So remember those days earlier when a lot of campaigning or advertising used to happen through newspapers, putting billboards, and so on and so forth. So nowadays the race to disable, they are making use of cookies in order to tap the data from the consumers. So log file analysis is another tactic that advertisers use to see the things that interest to us. So they are able to cluster results and segment user groups according to who may be interested in specific types of products. The another one that comes into picture is retail and e-commerce. I think I need not speak much about retail and e-commerce because it's a festive time, and most of you are uh, buying it online due to several reasons. So machine learning is heavily used in retail, both in e-commerce and in at high level. The obvious use case is the loyalty card. So I think you are very well aware of, suppose if I would like to uh, buy a computer, and if I try to look at what are the various types of computers and what are these rates, so the very next day you will notice that you will be getting a email or some kind of information will be available on your account that the prices of these computers have been changed, it has been dropped down. So how this kind of information is being transferred? So these are some of the algorithms that run behind, and it will learn what is that you want like to buy. So depending on that, it is going to give you some kind of suggestions or recommendations using which you can do the needful. And this is how you can how the data, this is how the data is collected from the point of sale and fed back to the database. So this is how machine learning comes into picture. So apart from that, we have gaming analytics as well. And apart from that, we have the internet of things, wherein as I said, a lot of things are being connected on the net. And apart from that, we have one more bit that is called as medical and healthcare. So this is another important aspect where machine learning has gained prominence. So now, coming back to this particular statement, what is that we were doing some time back? So if you look at with the when the computers was brought into the system, so what was the objectives some time back, about a decade back? So computers are being used in order to accomplish some well-defined tasks. So what are those tasks? So say for example, I have jotted down some tasks such as preparing result sheets, uh, uh, taking printouts of bank account transactions of each customer, billing, etc. So what are these what are the common entities that comes into picture when we talk about all these tasks? So this refers to, or what we used to do is that we had a computer and we know what are the tasks that needs to be performed, or the what are the tasks that needs to be accomplished. Accordingly, we used to write the program. We used to write the program, and depending upon when we execute the program, the required amount of data is being fed in. The computer used to operate according to the program that you are going to write, and it will be operated on the data, and accordingly the output is being thrown up into the outside world. So this is what we used to do in traditional programming. So the objectives were quite simple. I mean to say, it was just straightforward to prepare the result sheet. So the student has got so much of marks, 60 or 80 marks out of 100. What is the grading? So what is his percentage? So and bank account transaction. So the customer has credited 1,000 rupees, he has debited 1,000 rupees. So what is his balance? So such kind of simple task used to be performed some time back, and this is what is called as traditional programming. Now as the time passed by with the advent of the new technologies that is coming into picture, the objectives of the statement has been taken a revamp. I mean to say it, that so many challenges, we want the system to be utilized to do some kind of complex objectives, to accomplish some complex tasks. So what are those? So we have jotted some few: recognizing patterns, which comprises of, I want to recognize a particular person by identifying his face recognition. I want to identify a person's handwriting, or if he is speaking, I want to identify what he has spoken, medical images, generating patterns, images and motion sequences, recognizing anomalies. This is another important thing. Unusual sequence of credit card transactions. So there is so many things, so much of precautionary measures are being taken up into, are being taken up in order to avoid frauds that comes into picture when we talk about online transaction, credit or debit card. Unusual patterns of sensor readings, that is another important thing that one has to look over, because think of a scenario of a boiler. We will be using some sensors in order to detect what is the temperature inside the boiler. If the sensor fails, and if the temperature inside the boiler exceeds the permissible limits, and if there is nobody to take care of the boiler, then what is going to happen? It is beyond our imagination. So how to detect such kind of anomalies? These are some of the objectives that comes into picture when we talk. These are some of the challenges that we are facing right now. And apart from that, we also would like to have predict something called as future stock prices. This is one field where I was just discussing stock trading. So currency exchange rates. You can also include the gold rates as well. So right now you have witnessed that the gold rates have soared quite a bit, and we usually we want that the gold rates should to come down, and as soon as it comes down, we are eager to buy it. So we want to know, we want somebody to assist us, somebody to give us a clear indication when these gold rates are going to come down. So if machine learning can do such kind of processes, or if it can be able to assist us, then it would be of more help. So these are some of the challenges that we are facing right now. Spam filtering, fraud detection, as just now discussed, and lot of noisy data. So these are some of the challenges that we are facing right now. So how to counteract these challenges? How to overcome such kind of challenges? So we want there is a need to develop algorithms that solve problems like recognizing a face. So this could be the problem statement right now. So how to accomplish this particular statement? So we don't know what program to write, because we don't know how our brain does it. So if you look carefully here, the current problem is to solve if how to recognize if a person's face, and how to identify a person's face. So we usually do it, and we don't know how to implement it using a program. We don't know how our brain is going to do it. So even if we have a good idea about how to do it, the program might be very much complicated. So how to accomplish this particular task? So the solution is that ML is going to come to your rescue, and you can make use of machine learning algorithm, and it is being used widely, and you might have also used in your projects, or you have already adapted such kind of face recognition in various situations. And nowadays it is being made available right from your smartphones, cameras, and even in your television sets. So what this machine learning algorithm is going to do? So collect examples and produces a program that suits the job. So program produced by the ML algorithm may be different from typical handwritten program, and basically it contains millions of numbers. If we do it right, the program works for new cases as well as the ones we trained it on. So how this can be implemented is the question. So once again, we have the system with us, and we need to do some training. We need to train this particular program. How to train this particular program, or in turn the algorithm? So that is what we are trying to do here. So we have a set of data over here. We know what should be the output of this particular data, and this is how we are going to come out with the program or the algorithm. So you try to refer to this particular structure, whatever I am discussing right now. So this is the case of machine learning, and you can compare it with what used to happen in case of traditional programming. In case of traditional programming, the output was used to come on the right hand side. This is the output of the computer. Data and program were on the one side, will be the inputs. This is what used to happen in case of traditional programming. But in case of machine learning, you will notice that the data and the output will be acting as the inputs, and the program will be the output. This is what is happening in case of machine learning. So now already we have discussed about various machine learning are being used widely, and we have in this particular slide you can notice that machine learning covers almost all most of the areas, whether it is evolutionary models, neuroscience, cognitive science, in control system, data mining, statistics, so on and so forth. So now we have come to a stage wherein we know what is this machine learning, how what is the definition of machine learning, what are the use cases, what are the tasks it can accomplish, and how it is being used from past several decades. Now the question is how to implement it. So when you talk about learning, I mean implementing, basically there are three types of machine learning that comes into picture. One is the supervised learning algorithm. The second one is unsupervised learning algorithm, and the third one is the reinforcement learning. For simplicity, what is supervised learning? Let us try to consider a consider a simple box, okay, and that produces some kind of output when some kind of input is being provided to you. Now, if we already have a historical data that contains the set of outputs for a set of inputs, then the learning based on this data is called as supervised learning. So in case of supervised learning, what is going to happen is that we have a set of historical data, and this particular data has a set of outputs as well. Then the learning that is based on this particular data is what is called as supervised learning. A classic example of supervised learning is classification. So what is this? Say we have a sample of 3 flowers that is being taken into consideration right now. So all these flowers belong to a same category, iris. Now, how to differentiate between these 3 flowers? The objective is that I will be giving you the picture of this particular flower. You need to identify what is this flower, whether it is versicolor or setosa or virginica. So how this is being done? So we have the data sets, we have the picture with us. If this versicolor is having these parameters, so in order to categorize it, in order to classify it, we will be considering few parameters, maybe septal length, septal width, petal length, and petal width. And these will be considered as 4 different properties of a particular flower. Now we have done some measurements. We have done some. I mean, what you say is that we have collected some data. Say, for example, for 25 different examples for each type of flower. So this data would then serve as a training data where we have the inputs, okay, and corresponding outputs as well for this particular model. Now, using these training data and the desired outputs, we are going to build up a model. We are going to train the model. then a suitable this particular model is being trained in a supervised manner. It is being trained in a supervised manner. Doing so is what is called as supervised learning algorithm. Once the model is trained, we can then classify any flower between the three known types based on the sepal as well as petal measurements. This is what is being noticed now. So if you look at this particular diagram here, this diagram shows you after the some kind of experimentation is being done, some kind of processing is being done, or a particular ML model is being trained and is being implemented right now. So these are the pictures I'm going to get. So in this particular approach, you will notice that this is being used in order to visualize the data to create a histogram for each input variable. And these histograms are for 4 iris attributes. It appears that 2 of the sepal attributes have a Gaussian or a near Gaussian distribution. And this information can be useful in order to select an appropriate model or algorithm for prediction purpose. So if you look at this particular picture, this is another approach to inspect the data set. And if you look at here, all the diagonal pictures, you can have a look at the diagonal pictures to check the structured relationship between these attributes. So here we have the sepal length, sepal width, petal length, and petal width. Also, the same thing happens over here. So now this approach is what is called as multivariate analysis. And this particular diagram shows the scattered plots of all pairs of class attributes. And these plots are helpful in visualizing the relationships not easily detected when only reviewing numerical listings. So you should note that the diagonal grouping of some pairs of attributes in the figure, this strongly suggests that there is a high correlation between the attributes and that a likely quantifiable relationship is going to exist. Now, what are the some features or points that one has to make a note of when we talk about supervised learning? So when we talk about supervised learning, these are some of the points that we need to look into. One is that when this particular learning algorithm can be applied when labeled data is present. What do you mean by labeled data? Sometime back we told you that we have the training data and we know what is the desired outputs of this particular data as well. So this is what is called as labeled data. So supervised learning can be applied once we have the labeled data with us. And labeled data is used for training and testing. Labeling is often a manual process and it can be time consuming and in some cases it may be expensive as well. And every training data record is associated with the correct label, and it can be used for classification as well as regression. So just now I was talking to you about this particular example wherein I'm going to feed the data of all the flowers, and then I will take a snapshot of a particular flower and I will ask the algorithm to identify what type of flower it is. So it should be able to categorize this particular flower belongs to this particular category. So if it does that, then that is what is referred to as classification. Another point that comes into picture when we talk about supervised learning is regression. So regression analysis is being used for estimating the relationship among the variables. That is what we have done now. It tries to determine the strength of the relationship between a series of changing variables. the independent variables usually denoted by X, and the dependent variable usually is being denoted by Y. So if there is no dependent variable, it is called as a simple regression. Of course, it's a linear one. If there is more than one more dependent variable, it is called as a multiple regression. So what are the different methods, methods that can be used in order to implement this supervised learning? So typical supervised methods include Bayesian models. We have the artificial neural networks, SVMs, k-nearest neighbor, regression models, as well as decision tree induction. So however, we will not dive deep into this all these methods into these learning algorithms, because there is one more person who is going to come to my rescue in the next session. His name is Mr. Shankar Guri. So now quickly we'll move on to the next type of learning algorithm, that is called as unsupervised learning. So in case of unsupervised learning algorithm, the label data is not available. Unlike in case of supervised, the data will be labeled. So with unsupervised learning, there is no right or wrong answer. Basically, it's just a case of running the machine learning algorithm and seeing what patterns and outcomes do occur. A classic example of unsupervised learning is what is called as clustering. So that is what is being mentioned. Create an internal representation of the input example from clusters, extract features. How do you know if a representation is good? So this is the new frontier of machine learning, because of most big data sets do not come with labels. So this is what is being happening now. Consider the same old example as was described in the previous case in the supervised learning. So identification of a particular flower, depending upon the different attributes it is going to have, with the measurements. I am referring to sepal length, width, petal length, and petal width. So in this case, we don't have the exact names of the flowers for each set of measurements. All we have is the set of measurements, that's all. We don't know what is the name of that particular flower. So we are told that these measurements belong to 3 different types of flowers. And now we can use unsupervised learning techniques to automatically identify 3 clusters of measurements. However, as the labels, we don't know which particular measurement belongs to which particular type of flower. We can only categorize the flower as flower type 1, flower 2, and flower 3 respectively. If a new set of measurements is given, we can find the cluster to which they are closest and classify into one of them. So this is what is going to happen in case of unsupervised learning techniques, and are being used when no label data is going to be made available to the user. So the goal of clustering over here is to understand the data by finding the underlying structure of data. Clustering groups data based on some similarity measure. For instance, a company groups its online users into customer groups with similar purchasing behavior and demographics in order to better target them with the marketing campaign. So in this example, the similarities are the purchasing habits and the age group. This is another example I am citing right now. So since there is no label data, evaluating a cluster is not a obvious task to do. There is no ground truth that the result of a clustering task can be compared with. Clustering can also be used to represent data in a more compressed format. That is where reduction of dimensionality comes into picture. Dimensionality is a curse that we have received. So how it can be overcome? So these are some of the points that we can these are the takeaways from the unsupervised learning algorithms. One is that unsupervised learning algorithms is being used when there is no label data that is being made available to the programmer. So some of the most popular unsupervised approaches is clustering. That is what we have discussed. We have taken two examples. So goal is to understand the data by finding the underlying structure of data, and groups data based on some similarity measure. And just now I was talking to you about dimensionality reduction and data summarization. And in some situation or some application, it can also be used as a preliminary step for supervised machine learning algorithms as well. Last but not least, human and animal learning is largely yeah, sorry for the yeah. Yeah, so sorry for the interruption. I don't know what happened. Okay, so now these are some of the clustering algorithms that comes into picture when we talk about unsupervised learning. So this includes k-means clustering, hierarchical clustering, or in some literature it is also called as hierarchical cluster analysis, HCA or PCA. In k-means clustering, the algorithm groups data points into k groups, where k is the center of a group and is called as a centroid. I think most of you are aware of this particular word. The centroid is also called as the geometric center, or and represents the mean position of the data points of a cluster group. In k means clustering, the data points are k are added to the cluster. So this is how this particular technique is going to work. So hierarchical clustering, or HCA, groups data by creating a tree, by creating a tree. There are two approaches: a bottom up as well as agglomerative approach, where each data point starts in its own cluster, and the top down or divisive approach, where all the observations are put into one cluster and splits are performed in order to create the hierarchy that is usually presented. So these are some of the points that you can note down as far as unsupervised learning algorithms are being considered. So as I said earlier, we are not going to dive deep into all these algorithms, because it will be taken care in the next session. Now, quickly coming back to the next method of learning, that is reinforcement learning. So this is a special type of learning method that needs to be treated separately. So what is the learning action? To say, for example, learn action is to maximize profit, and there is no much information in a payoff signal is often delayed. So how this particular thing is going to work? So we want how this particular algorithm is going to work. So reinforcement learning algorithm is a special type, and it is quite separate from supervised as well as unsupervised methods. So reinforcement learning involves feedback from the environment. Hence, it is not exactly unsupervised. However, it does not have a set of labeled samples available for training, unlike that we used to have for supervised learning algorithms. However, in reinforcement learning methods, the system is continuously interacting with the environment in search of providing, or in search of producing desired behavior, and is getting feedback from the environment. So that is what is referred to over here, rewards from the sequence of actions. So reinforcement learning is concerned with how agents act in an environment by maximizing some notion of rewards. So this is all about the reinforcement learning. So now by this time what we have done is that we have taken care of three types of learning that comes into picture when we talk about ML. One is the supervised learning, another one is called as the unsupervised learning, and the third one is called as the reinforcement learning algorithm, or in some textbook it is also referred to as RLA. Now, what is this? I would like to bring to your notice what is this machine learning process comprises of. What is the process? How the cycle going to work? So this particular slide will give you a glimpse of how this particular actually process is going to work. So the process may comprise of the following steps. First one is the acquisition, the preparation, the process, as well as the report. So what does it mean? What do you mean by acquisition? So I am referring to the large set of data that are coming into picture, that we get from the outside world, that we get from the as the training data sets. Okay, so machine learning tries to machine learning tries to imitate the human learning on a computer system. That's what I have told. So human learning is mostly based on experience, whereas machine learning is based on data. So this is one point I would like to share it to you. So data is the starting point of a machine learning project, and it is used to train and test a particular model. That is what we have seen in our past several slides. So now the first step is to acquire, to collate all the data. So this make use of a data acquisition system, or you make use of several other resources and collect the data. So the first thing is that you need to collect the data from many sources. It may be from your organization, or you can also collect the data that is available from the internet, blah 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 blah. Now, and then the next step that comes into picture is that preparing the data in the right format as per the requirement. So this involves data cleaning and quality of data, and there may be one data set or there may be 10 or there may be 100 sets of data that needs to be looked into, that should be cleaned, and it should be checked as well. So you must come to accept that data will be need to be cleaned and checked for quality before it goes to processing stage. That is where we have mentioned it in the third option. So running machine tools, I mean implementation of the algorithms. So now the last one is the uh, presenting the results. These processes occur during the prepare phases, and the processing phase is where the most of the work gets done. The machine learning routines that you have created performs during this phase, and in the last step, or in the last stage, the reports will be published or presented, and it can happen in two ways, such as reinvesting the data into a data store, or reporting the results as a spreadsheet, or actually as a report as well. So this is how you can collect the data, and once depending upon the requirement, you can also feed the data back depending upon the situation or the application. Now, I would like to share to you how this particular machine learning we have adopted in a particular project. So, in our organization, I have guided a particular project wherein the overall gist of the project is that to predict the failures in the motor, in order to predict the maintenance, the type of maintenance that we need to provide in a particular motor. So this is the overall block diagram of our project. Basically, we have an induction motor, and it is being firmly on a rigid mechanical frame, and we will be, in order to, as I said in the previous slide, data is one of the important aspects, and without data we cannot do anything. So in order to collect that data, we will be using several sensors such as current sensors, sound sensors, load sensors, as well as the speed sensors. And using these sensors, we are going to collect the data that is pertaining to the motor. And as you already know, that motor is going to convert electrical energy to mechanical energy. So how to how to study the behavior of this particular motor? So that is being done by doing some kind of a load arrangement. So we'll be loading this particular motor, and we are going to check out how this particular motor is going to behave by getting the data from all these sensors that are being mentioned over here. And somehow we are also able to control this whole process using a PLC. PLC stands for a programmable logic controller, and you can also control the speed of the motor by varying the by using the VFD, variable frequency drive, and the whole system can be operated remotely by using an HMI screen. So the HMI may be as simple as your computer model or even your mobile. That is what we have tried to do. So you are in a remote location, and you want to know what is the statistics, how your motor is working. So this is what we have done, and this is the setup, actual setup that we had done in our lab. And this is what I was talking about. This is your induction motor. This is the this is the loading arrangement that we have done, and this is the mechanical frame I was talking to you about, to which the motor is being rigidly fixed. And if you can note here, there are so many sensors that are being connected in order to suck the data from this particular system, and the loading is being monitored by using this particular sensor, and you can change the load by varying this particular knob. And the whole system is being connected to the computer. This will act as a, I mean, this is being done in order to analyze, and we are trying to ascertain how this particular motor is behaving, and if there is any abnormalities in the motor, such as if there is excessive noise in the motor, then the system or the model that we have developed, it should specify that there is a problem with the bearing, or the motor requires some kind of maintenance, some kind of oiling or greasing has to be done at the motor shaft because the noise is above the permissible limit. So if the current, if the motor is drawing more current, then it will give a symbol that there is some issue that is happening in the motor. And if you start continuing in the same situation, there may be damage happening to the motor. So such kind of indications will be made available to you, and all such kind of analysis is being done, and that is being, and whatever the machine learning algorithm we have implemented is being running on this particular system. And this particular box, we call it as a controller box. In order to have a safety features, we have used all the MCBs, and this is the HMI screen that we have used in order to interact with this particular system. So now what I would like to communicate to you is that this is the snapshot that we had obtained. And if you look at here, so there is some kind of abnormality that we have detected, and this results, or this is going to ping back to the user or the owner or the person in charge, stating that such kind of abnormality has occurred in the motor and it requires immediate attention, and if you do not provide immediate attention to that, then it may harm your whole system, or it may undergo some kind of major repair, which is a costly affair for an industry. So always that when we talk about industry, they want to ensure that the products, I mean whatever the units they are having right now, are quite reliable. They can sustain for a longer period. So this is what is the overall gist of the project, and this is the scattered profile that we have obtained. And here we have used a principal component analysis in order to determine the abnormalities of the motor, and try to check what is the health of the motor, how good the motor is behaving right now. And we can there is also a prediction wherein you can also predict for how in the present stage, if the present situation continues for another month, what would be the status of, or what would be the health of the motor after 1 month or 1 week or 15 days or 2 months, so and so forth. So if you are able to do so, then it gives a sigh of relief for the investor, for the industry people, so that they can have a relief. So okay, my motor is not going to harm me anymore, and I can take good number of orders, and I'm totally, because I can deliver the products within the well-defined dates. So this is how the industry people are going to, I mean, look at it. So it's a very important factor, and I would like to mention here that this particular project has bagged the third appreciation prize in the national automation competition that was being organized by Mitsubishi Electric India Private Limited, and this was a national event that was held at Faridabad near Delhi. So the gist is that how machine learning algorithms we have adopted in our projects. Just I wanted to share this particular information, so you can also do the same, and you can also ask your students to take it forward in their academics. So coming to the last slide, I want to end up this particular session with the last slide. So what is that we have discussed is that we have discussed about artificial intelligence. We have looked at where machine learning actually lies when we talk about artificial intelligence. And this particular figure also shows the sub areas of machine learning and summarizes the tasks. So machine learning comprises of, we had discussed about supervised learning, unsupervised learning, as well as reinforcement learning as well. And we did discuss about classification, regression, clustering, and dimensional reduction, reward maximize. However, in other the literature, other classification of machine learning methods are also available, but have not gone in depth into all those methods. So with this, with all these concepts, there is a need to be always that at the back of the mind when solving some real life problems and building artificially intelligent systems. All these concepts are going to help you in a long way. So with this, I would like to end this session. So if you have any question and answers, I'm here to clarify your doubts.
Participants, if any queries are there, professor is ready to answer. Please raise your hands or write in the chat box.
Yeah, okay. If some of the participants are okay, I need to open the chat box also. Chat box.
And if there are no queries, then I must say uh, I am very thankful to Dr. Santosh R. Desai sir for his nice and detailed presentation on machine learning, brief history of machine learning, its applications, neural networks, and their applications in day-to-day life. And another important thing sir has highlighted is the real-time applications of machine learning in controlling or in predicting the healthiness or the working conditions of the motor. Sir, I think it is very interesting to use this machine learning algorithm in predicting not only your the healthiness of the machine in day every day life, in whatever the engineering field, we can make use of it. So it is very interesting, sir. You have also, it is, I think it is a sponsored project also for best project selection.
Yeah, 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 yes, sir, yes, sir.
And we are very proud of you for making use of this advanced technology in your applications. And sir, I'm very thankful for your wonderful sessions. I hope the participants are also very happy with your presentation and discussions. And on behalf of our PDA College of Engineering Kalaburgi and on behalf of E and C department, particularly on behalf of myself and other faculties and staff, our heartfelt thanks to you, sir, for spending your valuable time and sharing your rich knowledge of research with us and participants. Thank you very much, sir, and we will look forward to your cooperation in future as well.
Yes, sir. It was my pleasure to share the knowledge, and you are always welcome, sir.
Yeah. Thank you, sir. Now we will hand over this session to the next speaker, Shankru. I think Shankru has joined.
Yeah,
Yes,
Mr. Shankar is already here.
yes, sir. Yes, sir. Yes, sir. Good morning, sir.
Good morning, Shankru. And now I request our colleague, Moinuddin, to introduce Dr. Shankru in a brief way. Moinuddin, please.
Desai, sir, you close your share screen.
Ah, yes, sir. Yes, sir. Yes, sir. Yes, sir.
We have with us Dr. Shankru ji. Welcome, sir. So, I will just read out his brief yet impressive biodata. He is an active researcher in the area of machine learning and working as a principal data engineer at Query Data Systems, Bengaluru. He has worked as project fellow under UGC sponsored project in the Department of Computer Applications at BMS College of Engineering, Bengaluru. His interests are machine learning, Internet of Things, and other related fields. He has contributed R code for a textbook, Data Mining, in textbook companion project under free and open source software for education project run by IIT Bombay. He is serving as a reviewer for few reputed international journals like IEEE Access, Array, Elsewhere Science Publication, etc. and also few international conferences. He has won Best Paper Awards in prominent international conference. Currently, he is editing a book on COVID-19 pandemic with Elsewhere Science Publication, along with fellow researchers from USA and Mexico. He is also a guest editor for upcoming special issue on engineering and applications of artificial intelligence, Elsewhere Science Publication Journal, on applicability of graph convolution neural networks in healthcare. So I am very happy to have you, sir.
Thank you, Mohanindin.
I will hand over session to you, sir.
Thank you, thank you. Okay. Is my screen is visible, Mohanindin?
Ah,
Yes, sir. Yes, sir.
But
Kindly adjust the camera, sir.
come again?
Kindly adjust the camera.
The camera is on only.
Now you are. Yes. Now you are visible, sir.
Yeah, but screen is paused. The screen sharing is paused. It's showing.
We are able to
I
see
will do
you,
it
sir,
one
and-
more time.
Yes.
Uh, is my screen is visible, Mohiddin?
Yes, 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 sir. It is visible, sir.
Yes. Yes, yes. Thank you. Uh, good morning to all. Just today we are just going to see the deep learning for beginners. Yes, Santosh sir discussed some preliminary concept about ML and its learning stages. I think now you are aware of the learning concepts with respect to ML. Just I am going to give some brief introduction about deep learning, okay, and its short history of deep learning, and the one important concept called convolutional neural network. That's what I am going to give some brief introduction about that. Then we will see some graphical convolutional neural network. Then we will conclude with the some practical exercises by using the Google Colab. Okay, let's begin our session for this session. Okay, so this is the short outline of my talk, today's talk. That is a short introduction about deep learning, that's history and why deep learning required. Then comes to convolutional neural network. What is that convolutional neural network? What are the components it's contained? How it helps to classification problems. Then finally some conclusions with respect to this basic introduction about the deep learning. Further, just you understand the trend of deep learning and machine learning with respect to the research as well as today's market usage of these technologies. From the figure, you can understand that the machine learning as well as the deep learning are going parallelly in a same way. How the machine learning grows, like that the deep learning is also going. If you look at the year 2019, 20 until now, the trend is same. That's why the today's trending technologies are nothing but your machine learning. In that machine learning, you have a deep learning. Then apart from it, you have a combination of deep learning as well as the IoTs or the combination of other technology like sensing technology or AR, VR technology. So these are the trending technologies of today's world. Let's move on. What is this artificial neural network? Before going to deep neural network, just I want to bring some notice to you people that what is artificial intelligence? Artificial intelligence means you are going to take to perform certain tasks by injecting some intelligence to the machine. As you have heard in your previous sessions that neurons. Okay, so those are things are there in our brain which is help to understand and perform certain tasks with respect to the humans. Likewise, we want to mimic that technique to how to apply that technique to our machine learning algorithms. So that is nothing but a artificial neural network, artificial neural network concept. That is nothing but here you have there we have a neurons, some synapses, simple, since based on that some axons, dendrites will be there. So those dendrites will get the information. After that, they will process them and the output will be given. So that is nothing but your brain. Here also same thing, you have a inputs, you are going to adjust your input based on the weights. So finally you are going to get some outputs. That's what the ANN says. Next, move on. See, this is the basic structure of your brain architecture as the your artificial neural network. In your brain architecture or your neuron concepts, you have a nucleus that is nothing but a your main processing part, and you have a that is the processing part, and your dendroid part. Dendrites are the features gathering information, gathering things. Then the information flows through the axon. That is normally with respect to the brain. Similarly, in ANN, we are going to use your inputs as your dendroids, your squash functions or some function as a nucleus, then you have an output. Like that, axons, you have an output. So similarly, we are mimicking the human brains here to get the information, to get the output of your inputs. Okay, similarly, we have this structure of the node, how the node look like. Node means here the input or your features. That is nothing but here input is 4.7. This is somewhat inputs. We have some input. For some input, some information will be processed using the squash or the sigmoid functions or ReLU functions. Then you will get the output. That is the structure of the node. You have a squashing functions, that is the non-linearity functions, which is going to perform the non-linearity operation to get the proper outputs. Okay, so similarly same thing I am showing again here. Synapses comes again weights. So here the axons, as I said in my previous slide, axons are nothing but the information flow. So here you get the synapses. From synapse you get the information or dendrites. That flow will be maintained using the axon. So similarly, how we can mimic the same concept in our neural network or in our system? That is nothing but a neural network. So here what will happen? You have some inputs, for that we have some outputs. Okay, to process them, you have some hidden layers. If you see in your previous lecture, your resource person might have shown you how the things will work with respect to the perceptron, all those things might have said that. So based on that, whatever the inputs you are going to perform, the information will be processed in the hidden layer. Then that hidden layer will be given to the output. That information output from the hidden layer will be given to the output layers. There is nothing but a simple neural network. Simple neural network, that we can say it as. But in your perceptron, only you have an input, some squashing function, then you have an output. That is nothing but your perceptron concept. But here in multi-layer neural network, you have a more than one or two neural network. More than one or two. More than if you consider the neural network, more than two is a deep learning. It's a deep learning technique. Okay, that's what the deep learning says. So comes to the what is deep learning. So you can see, you can observe from the figures here that in machine learning, what is the difference between machine learning and your deep learning? See, from the figure you can observe that you have a inputs, like whether you want to identify that as a car or a bus. So then what a machine learning algorithm will do, it will extract some features, then that information will be flowed to the some classification model, then you will get the output. That is nothing but your regular machine learner algorithm, as Charles Santosh sir described. Just you will get the feature extraction from the input, then your model learn from those features, then your model will provide you the some output. That's nothing but your machine learning. Okay, in deep learning, what things will happen here is that here there are so many layers. Like you have a car, input is your car. From that input, there are some layers. Those are nothing but your hidden layers. For example, in the figure, you can observe that here around 4 layers are there, 4 hidden layers are there. Consider there are 4 hidden layers. Then what each hidden layer will do is extract in each layer features are extracted and process them there itself and identify where the error occurs, whether it is reaching the required output or not. If something goes wrong, it will identify itself to correct it, then it will process it again, then it will provide the output. Like that, deep learning will provide. Means in hidden layer, in the hidden layer only everything will be performed and the error will be adjusted. There might be the gradient descendant or back propagation technique. There are so many techniques are there to adjust the errors. That is nothing but your deep learning concept. Similarly, you can observe in another figure also same thing are explained. Okay, this is what the deep learning says. Then why you require the deep learning? Suppose in your normal ML concept, what will happen? You are just going to extract the feature at one time. So you are not going to process them multiple times. If once you extract the feature, if you are unable to extract the important features from the input, then your machine will diagnose it or recognize it in a false, right? But in deep learning concept, what will happen? Your input will be recognize it so many times. Okay, based on your hidden layers. Okay, it will recognize or process your input information so many times. Then it will extract that important information from each input, then it will process to the output. Then why your DL is useful? Useful means in the form of getting the good features, getting universal features. Then one more concept called the end-to-end system. End-to-end means whatever the information is there in your feature, so whole thing will be extracted in a multiple layers, multiple layers, so that it is not able to unrecognize the important point in the feature. So that's why the deep learning concepts are very useful. But the one disadvantage with respect to DL is that it takes a long hardware requires too much. Your normal CP, if you put large amount of training data, then your normal PC won't work. So for that you need gigabytes or petabytes of processing capacity. If your data set grows in terms of gigabyte or gigabyte, then your processing capacity also be increased. So that is nothing but your deep learning concept. Why your deep learning is important? Because nowadays, as Santosh sir said, nowadays everywhere big data. In terms of big data means it has one amount of data. Every second you will get a huge amount of information from the industry point of view or from the another research point of view. So that's why your deep learning concepts are very helpful. But the disadvantage with the deep learning concept with respect to your timing and as well as the processing capacity, your hardware capacity must be good. So come to again this feature. You just observe the trend as you can observe in my previous slide. There also I showed the trends of the neural network or deep learning concepts. Here also you can see similar pattern it is showing in 2004 to 2015. It is also showing same thing as you can observe my previous slide. So the trend is continuing here. So now comes to directly the deep learning. So deep learning here is, in the first you can observe here is that this is the input layer. Then comes to first layer, you are going to train, that is the, then again you are going to train, then again you are going to train, process it, then again you are going to train it, then finally you have output. Like that, you have a multiple layers. Once you give inputs to the input layer, that will be processed into number of layers, how many layers you want to process. So it will process till that layer, then it will give your output. That is nothing but a multi-layer neural network. Okay, this is nothing but a multi-layer neural network concept. See, suppose you have an input, there's nothing but a encoder decoder format. So whatever the things will be there in your input, that will be encoded. Okay, that encoder, that's nothing but we can say it as a encoder. It is used to train your inputs. Then you have a outputs. Okay, then you have a output layers. So this is a small representation of how your encoder and decoders works. Encoder, what encoder will do? Your inputs will be taken care by the encoder, and your output will be given by your decoder with the help of hidden layers. Okay, this is the simple representation of your neural network. So that's what I have mentioned here. Hidden layers are very important because those are the processing unit, like your CPU as a processing unit. So here in your neural network, hidden layers are your processing units. So then comes to the intermediate layers for each trained autoencoders, means these are whatever these things which is showed in the block, those are nothing but intermediate layers. Means each layer performs each task and gives output to the next layer, and next layer will perform some task, then it will go to another next layer. Like that, it will perform the task and identify the errors. Okay, if error is there, then gradient descent or the backmotion technique is used to minimize the error, then enables the output and enables the correct output. That is nothing but your intermediate layers. Then comes your output layer. Output layer means your final layer, that which predicts your task, whether it is a cat or dog. In my next coming slides, I will show those things you again. So suppose you have some dog images and some cat images. This is a very popular example in deep learning concept. Suppose you have some 100 cat images and some 20 to 30 dog images. So you will give those images to your inputs, those images as a inputs to your neural network. Okay, then what it will do? It will process those in the hidden layer. Okay, train your neural network using those images. Then it will provide whether, and then it will say whether it has a cat or dog by observing its feature, by extracting its feature. That is nothing but your class, whatever you can say, it's a class or an animal or a label, whatever you can say. Similarly, if you provide them a dog, it will give as a output as dog. Okay. So now comes to the taxonomy. Taxonomy means what Santosh has mentioned. Professor Santosh has mentioned there is supervised learning, unsupervised learning, reinforcement learning, and other kinds of learnings also is there. Those are based on your application perspective. So in recurrent system or GNN, general adversarial network, you have so many neural networks. In that scenario, you should learn the system. We need to perform those things. Generally speaking, deep learning taxonomy has supervised, as mentioned by Santosh, and unsupervised. In supervised learning, we have a convolutional neural network that is described, that is developed by Lee Kuan. Recurrent neural network, that is another neural networks. So that is also based on the sequence of steps. If you want to perform certain tasks, as mentioned by Santosh, in mechanical devices or some other devices, you need to perform certain tasks step by step. That is a routine job. In that scenario, you can use this recurrent steps, recurrent neural networks. If you use the DAM means that I said earlier, as I mentioned earlier, generative adversarial neural network. That is nothing but if you want to mimic the images, like other person, what other person says, if you want to mimic that images, or you can aim at automate, annotate, if you want to make some annotation, then you can use that GAN techniques. Then there are some unsupervised technique, that is deep belief networks. Here also you are not going to train the model, just will give the inputs to the neural network itself performs itself, trained by itself, then it will provide some output. But its output is not guaranteed, because if your input data itself wrong, then your output will be obviously wrong. Okay, unsupervised learning has suffered from that. If you see the clustering technique, so that is nothing but an unsupervised technique. If your data is not correct, then your output also not correct. If your data has a class imbalance means, if suppose you assume that you have a cat and dog, suppose you have 100 dog images, only 20 cat images. In that case, whatever you are going to feed to your network, it will understand that everything is dog, because your cat is only 20. Okay, whatever the information you are going to give to your neural network, it will say only dog, because your neural network has not trained with the cat features. That is nothing but your class imbalance. That's a class imbalance problem. In real world, that is very big challenge. Okay, getting a good quality data and useful information is very difficult in real time. For that, we need to process the data. See, someone says, some scientist says that if you want to do a ML project, at least you need to spend 70% of your time into processing it. Means your data cleaning. That is the concept with respect to data mining. Okay, so like that much of amount of time it takes. That is nothing but the unsupervised learning. So these are some of the well-known unsupervised learning in deep learning. Okay, those are nothing but deep nets, stack denoising autocoders, sparse autoencoders. Why I am mentioning these? You can use these for comparison purpose. If any research scholar is there, or anybody is working with respect to these, you can use these method for the comparison purpose in your paper, so that your reviewer can understand that your method is performing better. So that's why I mentioned these things here. Next comes to our convolutional neural network. See, convolutional neural network is one kind of neural network, okay, which works on the convolution layer concept and pooling layer concept. Okay, I will go through those things. Okay, this is one kind of deep learning technique. So this is widely used in real world application. In so many real world application, this convolutional neural network is used. So he is the person who is developed this technique. Okay, and Lucena, he is the person who is the researcher. Now he is with this New York University. His supervised guide is Yashoi Banga. Last year he came to India for one international conference. Okay, he is also a very good researcher in the domain of CNN. So what is CNN? Then comes to why CNN, what CNN. These are the something we need to address. CNN is nothing but, as I said, CNN is nothing but convolutional neural network. Convolution means what? You have some neurological concepts. Okay, you will use some filters. Using those filters, you will get some useful information. Using those information, you are going to classify it. That is nothing but your CNN concepts. Okay, so I will tell in the upcoming slides. I will tell what are those. Okay, this is also a multi-layer neural network. As I mentioned, deep learning is nothing but more than one layers. This is nothing but convolution neural network also has multi-layer neural network. So this is a feed-forward network. Feed-forward network means once your input is given, then it will directly go to hidden layer. From hidden layer, it will directly go to the output. That is nothing. Whatever the input you are going to give, it will directly go to the output. That's another feed-forward network. If something goes wrong, if you want to, if your machine is giving errors with respect to your class, then prior propagation will be performed using a gradient descendant. Then it will rectify the errors, then it will give the output. So recognition of the pattern is very useful with respect to the convolutional neural network, but it takes huge amount of time. That is what the disadvantage of your CNN. But recognize wise, it's very useful and very practical. See, next in this slide, just you can observe here that the whole architecture of your CNN. So whatever you are going to do here is that you have a inputs in the form of cat or dog. Suppose you have a cat and dogs, you will put those in a convolution input layer. Then those things will come to the convolution layer. Then those will be processed into cooling layer. Then again convolution layer, cooling layer. Usually only convolution and cooling layers are the main one layer. Okay. Then convolution cooling is another layer. So you can put how many you want. You can repeat them how many times you want. No, those are nothing but your hidden layers. Those are nothing but your processing layers. Okay, that is nothing but your convolution and cooling. Then comes to the flattened. Flattened means why we are doing flattened is that whatever you are calculating in the convolution and cooling, those will be in the form of vectors. To convert them vector into matrix, you are going to use the flattening technique. So, okay, that is what we are going to do. Sorry. Hello. 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 Hello, sir.
Hello.
Monitin, is it visible? Hello.
Hello. Yes, sir. It is visible, sir.
Shankar, it is visible. You please carry on. It is visible.
Yes, sir. Yes, sir. Yes,
Your
sir. Yes,
voice
sir.
and your PPTs are very much clear.
Yes, sir. Yes, sir.
I am audible to you, Shankar.
Yes, sir. Yes, sir. Yes, sir. I am audible, sir. Audible, sir.
But I think you please kindly adjust your camera because your half of the face is visible.
Okay, 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 okay.
It's okay. It's fine.
Okay.
It's fine.
Now is it clear, sir?
It's fine. नहीं 5 minutes better yeah. Okay.
Okay, this is sorry for the interruption. Next, we'll see the main. One second, one more column. So this convolution neural network is the one kind of neural network, as I mentioned. It will be conversation, what things happen, and max pooling, what the things will happen. We'll just look into the concept behind with respect to the each layer. Then just to see that convolution layer, what the things will happen in convolution layer is that it extracts the features from the input image and maintain the relation between the features. That's what your convolution layers does. Suppose you have an image, cat and dog. What it will do, what it will identify is that it takes the important features. Important features is nothing but your eyes will be there or your nose. So those are the things Those are the important factors with respect to your image. So those are the important factors will be captured in the convolution layer, and those will be preserved for the classification purposes. Let's consider one image. Okay, so this is an image. So in that image, this is pi into pi image. In that image, so what we'll do is that we take this some information, means some filters. Some filters means it's a scanning thing, scanning purposes. Suppose you can see that filter is nothing but you are going to put these whatever the filter matrix is there on your image, and you will get the some useful information from that image. I will say what are the, I will discuss the filters in my upcoming slides. Okay, just you understand that you have an image and you have some filters. Okay, so once you put your filter on your image, it will process. That is nothing but a feature mapping. It will take useful information from the image and stored it somewhere. That is nothing but a somewhere in the process. That is nothing but your feature mapping concept. So this convolution feature is very useful for edge detection, or whenever your image is not clear, or whenever you have want to apply some sharpness in the image. So in that scenario, you are going to use these filters. So these are some filters we can use. That's nothing but identity matrix. This is nothing but identity purpose, edge detection purpose. We have so many filters. Sharpens for sharpen. If you want to get sharpen image, you have some filters for box. You have some filters like that. You can define your own filters, or you can define your own filter based on your applications. Okay, that is nothing but your filter comes. Then comes to the strides. Strides are nothing but, suppose you have an image. Suppose you have an image like this in this. So suppose you have an image here. Suppose you want to shift from 1000 to 1100. So you shifting of the scanning or filtering, that is nothing but your stride. How many number of pixels you want to move? That is nothing but your stride. Stride is nothing but the number of pixels you want to shift in a input matrix, in your input matrix. When the stride is 1, then you are going to move that in a 1 pixel. When your stride is 2, you are going to move you are shifting your input to the two pixels. That is nothing but stride. Padding is one more concept where nothing but when your image is not perfect, you want to know patching up. You can say in your normal word patching. If you want to perform neatness, you want to if your image want to look clean and clear, you need to do some patch up works, right? So that is nothing but a padding concept. Padding means just you are going to add something to it. Here, what we'll do, you will add some zeros into it. If you suppose you are identifying image into 0 and 1, you are going to add as a 0. So if your image is not clear at that point of time, you are going to use this padding concept. If you are adding, you are putting some information. That's all. So then comes to your non-linearity function. Non-linearity function is means once your output is comes, it performs whether it's correct or not using the non-linearity. It performs the adjustment. It performs the adjustment with respect to the non-linearity. Whatever the inputs you are doing, that's the output you are getting. That is in the form of linear. We want to get that information in the form of non-linear. So that's why we are going to use the non-linearity function. The well-known non-linearity function is the ReLU because its performance is very good as compared to the other non-linearity functions. The other non-linearity functions are your tanh or your sigma functions. Those will also provide the result, but those are not that much good as compared to your ReLU. Next, we'll see the with respect to the convolution neural network. So suppose you have a maximum layer, so what is that? Sorry. Okay, so next comes to your cooling layer. What it will do does is that it get the information, it get the pattern information, whatever the information is given by the convolution layer, it takes the important images, means it reduces the image pattern and takes only the important image in the cooling layer. So there are spatial cooling, that is nothing at subsampling or downsampling. So it's mainly for the dimensionality reduction, means you are going to reduce the features with respect to the image or with respect to the data set. That's what your cooling layer does. Okay, there are so many cooling layers are there. The well-known cooling layers are max cooling layer, average cooling layer, sum cooling layer. Usually, in most of the research work, you can see the max cooling layer. Most research paper have used the max cooling layer for the better performance. Then comes to what the cooling layer performs. Suppose if you identify, once your image is scanned using the convolution neural network, so your features will look like this single depth slice. Suppose you have 1 1 5 6, this is the 2 by 2 matrix. Suppose your filter is 2 by 2, then what it will do is that it will take the maximum value. Suppose in the first 4 blocks we have a 6 is the maximum value. It will be put in the max layer, max cooling layer. So you can observe here that 6 has taken. Here in the next 2 by 2 matrix it has taken 8. So which is the maximum value? It takes that information. Suppose in the third 2 by 2 matrix I have represented that in a different colors. That is nothing but other color. In that we have a 3. In next we have a 4. Like that, max layer will perform. It means your cooling layer will perform. So then comes to your fully connected layer. Once everything is processed in convolution layer and max cooling layer, then that output is given to the means flattering. Then what will happen? Your vector output will be the comes once the cooling layer ends. Then it is flattened. That flattened converts vector into matrix. That information will given to the neural network. The neural network performs the classification task. That is nothing but a fully connected layer. So this is complete CNN architecture with respect to the image classification. With respect to image classes, you can see is that first you have an input image like this. Then you have a feature mapping, means you have a convolution layer. Then again, if you have a feature map, you will get some information from the convolution layer. Then again, that is fed into your one more layer. Then again, feature mapping is done. Again, feature mapping is done. Then you have a convolution layer. Then you have ReLU functions. Then you have a pooling. So it will continue how many times you want. So again, it will flatten. Then that will be given to the neural network. Then you will get the output. Like that, your CNN will perform. This is the complete architecture of the CNN. So what is the short summary of CNN is that you need to provide some image to the convolution layer. So apply some filters or with strides. You padding if requires, performs use activation functions to find the nonlinear function, perform cooling to reduce the dimensional size, add more convolution layer until it satisfies. Means how much information, if you are unable to satisfy the output, then you increase the convolution layers or you increase the cooling layers. So better always you improve the convolution layers. So then you flatten the outputs and feed to the neural networks. So like that, your CNN will perform. So these are the popular CNN architecture, that is nothing but AlexaNet, VGNet, GoogleNet, okay, ResNet, LemNet, GFNet. These are the well-known, popularly available CNN architecture. You can feed your own data and find the output get the output from these. So then comes to the one more recently used, introduced convolution neural network are nothing but your graph convolution neural network. Graph convolution neural network is nothing but where you are not going to use any images. Okay, you are going to use the things based on the graph, but nothing but a node as well as node means your vertex and edges. Based on those, you are going to find the output of it based on your graph convolution network. What will happen in the graph convolution network is that suppose you want to classify, you want to identify molecular or your sense in the social network analysis to identify the similarity person, means you are going to recognize the similar people in the social network. In that case, you can use this graph network. So what will happen in graph convolution network is that it will take image or your input as a edge and vertex and edge that will feed into some layers, and that will be performed in some layers in the form of your vertex. Weight will be adjusted based on your output. Then that will be given to the convolution layer. Then convolution layer we have a filters. Then you have max pooling layer. There also you have some layers, but those are not called as a max or pooling layers, just layers. Then you have a ReLU functions to know, as I mentioned in my previous slide, to get the non-linearity in the output. That is nothing but your graph convolution network. This is very new topic. You can work if anybody is working on neural network, you can usually just go and do search on this graph convolution network, neural network, because if you put paper on this, your paper acceptance chances are more, because it is introduced in 2015. So I recommend who are working on this, means in deep learning techniques or deep learning concept, you can apply this graph convolution network. Only those who are working in the social network analysis and molecular biology or medical imaging, you can use that. But with respect to non-images, it's very good. That's what I understood from the literature. And we are offering, as Mohiddin said, we are offering one special issue in engineering applications in artificial intelligence. Okay, that is headed by the Ajit Ibrahim. He is leading that one. I am also guest editor in that. If anybody want to put, you are welcome. That is opened by this December 1st week. We will open that. Okay, you can put. So my conclusion remarks with respect to this session is that we understood the basic concept with respect to deep learning. Okay, how the deep learnings are there, what are the components are there in the deep learning, and we elaborated the CNN thoroughly, and we looked into each layer, what are the things are there in CNN, like convolution layer or your pooling layer, some flattering technique, and then comes to your fully connected layers. So these are the conclusion remarks with respect to this session. Okay. Now, just I want to go into some practical things. That is nothing but just you go here and see there. There's a popular software called, means everything is freely available here. That is Colab, Google Colab. If you use this Google Colab, everything is there. Whatever the concept I have mentioned till now, everything is there here. Just you need to know execute it. That's all. Just you need to execute. Just check here. Okay. See, these are the deep learning basics. You can go here and see they have built their own model. For using this, you need a Gmail account. Okay. If you use Gmail account, you can directly get into this Colab, and already the code are written here. Okay. for the well-known data sets, they are already written the codes and they already perform the task also. You can observe here, if anybody use the Jupyter notebook, those are very familiar with these kinds of stuff because these people are use Jupyter notebook in their in this build-up. So you can use this, okay? So in this you can use how to train the model, how to build the model, how to get the classification accuracies, how to write the code. See, you can see the classification of MNSFT with convolution neural network, how to build the a model, how to train the model. So all these things are there. Just you need to search. That's all. So just now I have done here. Just accuracy you can obtain here. See, 99.13 accuracy. It's because it's already trained. So every time it is training, you will get high accuracies and making the predictions also very good. Its very usage is very good, and you can use use amount of data in here in using this Google Colab because your normal PCs are unable to process the huge amount of data. It has the option of using the GPU, okay, and other kinds of stuffs. Okay, you can use of it. If anybody is working on this, you can take help of this. Okay, then you can see the one more convolution example here. So like that you can see so many options are there, already available are there. Just you need to learn how to use it. That's what I want to say. And if anybody have any doubts with respect to this, or as well as if anybody want to do some questions with respect to their research, those are welcome. For my email ID, I will mention in my last slide. You can directly send me those, whatever the problem you have, so that I can help you in terms of your research work. Okay, you can use this, and you can use also the Python with the help of Keras. Also, you can perform these tasks. But this is very easy for beginner. It's very easy. You can only import your inputs. You will get the output. If you have to do some minor changes with respect to the code, because already code is there. Just you need to tune some codes based on your inputs so that you will get the output. I think for researcher it's very helpful. You can use that. Finally, I thanks to Nagendra sir for giving the opportunity to discuss, to share some amount of the knowledge whichever I have earned during my work. So thanks once again to Nagendra sir and his team. Thank you, sir. That's all from my end. If anybody have any questions, then I'm happy to take.
At the outset, I am very thankful to you, Shankru sir, for your wonderful and excellent presentation. But there are two participants who are going to ask you some questions. I request you to stay on.
Yes, sir. Yes, sir. Please, sir.
There is one participant, Sapna Sharma, is asking how to decide which type of CNN net is used. And the same question related to that only by the same participant. Can we use deep learning concept for image security and or in encryption?
Yes, sir. We can use that. Image security, you can use that. But you need to see the image size. First of all, one thing is there. Because if too much image to high resolution, the clarity of the image is very important to recognize the deep learning concepts and what kind of application you want, whether you want to mimic that or you want for the classification purpose or you want for the generating purpose. So based on those things, you need to choose. If you want to mimic the images, then you can go for the GNAN, that is nothing but generative adversarial neural network, or you want to repeat your process like your mechanical process. In that case, you can use the recurrent system, recurrent neural network. So based on your application, you can go for security. I recommend you to go for the convolutional neural network. Okay, you can go for that. Highly recommend you to go for the convolutional neural network. Hope you get the answer.
Yeah, the same question from the same participant, fingerprint for authentication. Of course, I think it can be used. One participant is asking whether this deep learning can be used for the fingerprint for authentication.
Yes, we can use. You can biometric also we can use, no problem. No problem. You can use. No problem. There is a well-known researcher in biometric from the Indian Institute of Science. His name is Deepak. He is also using in biometric for the biometric for a 3D printing or a 3D recognition. Those people are using that.
Okay.
You can look into his.
And there is some compliment from the participants to you. The session is very informative. It's from Yuraj, and also there is one query and also compliment from the another participant, Guru Siddheshwara Ranoji, and he's asking, he requires the explanation regarding the weights, how to decide the weights of the neural networks.
Yes, that is a very tricky question. Weight adjustment is done by the neural network itself. But I think based on your application, if you share the application so that I can give the my inputs based on my experience. But usually weights, if you keep the weights low, then your accuracy will be more as far as my knowledge concerned. Because I worked in COVID situation. We just to identify the whether this person using the lens or his body CT scan image, we are going to identify whether this person has COVID or not. In that case, we used very low weights, so we identify very good results that we are publishing. Soon it's going to publish. Yeah, in the sign elsewhere. Yes, sir. If you mention your application based on that, I can tell that.
Thank you very much, Shankar. There is one question from my side.
Yes, sir. Go ahead, sir.
Yeah, how you are going to decide the number of the hidden layers? How you shall decide how many hidden layers that those can be put in the neural networks?
Yes, sir. Again, this is a no. Again, I will say this is based on the expertise of the subject. See, again, if you in some applications, if you use one or two, means more than one till 2 to 4, you will get good results. But if you apply the same thing in operational research kind of steps, there it may go to up to 10 layers also. But the competition will be more in that cases. So I think based on your image size, if you are working in image, that is one thing is matter. And if you are using the direct data sets, there the hidden layer capacity will be observed. That's again the trial and error method. Trial and error, you need to do that. But there are some standardization is there. Input minus outputs or output minus inputs. So inputs divided by 2, like that. So many things are there. You just need to explore them. That's all. There are so many. There is no pakka, means there is no actual thing that you must have this many hidden layers so that you will get high accuracy. That's not there. That is trial and error method. Based on your application, you can do it.
Thank you very much, sir, for a very informative session. And we hope the participants have also benefited from your rich research experience in this particular field. Sir, I thank on behalf of our college, PDA College of Engineering, Kalburgi, and on behalf of E&C department and the faculty and staff of our department to you for your wonderful sessions and participating and delivering a excellent talk on this occasion. Thank you very much, Shankar sir, and we will look forward the same cooperations in future as well. Thank you very much, sir.
Thank you very much, sir, for giving the opportunity to share my knowledge. Thank you very much for you, especially. Thank you, sir.
Now I request the participants to stay on. The next session is going to be delivered by Dr. Nishant Jain from JP University of Information and Technology, Solan, Himachal Pradesh, on the application of artificial intelligence in biomedical image processing. Just I request all the participants to stay for 1 or 2 minutes. I am just waiting for the resource persons to join. अभी नहीं join हुए ना? One more information to all the respected participants is that tomorrow also we request you to join sharp at 10 o'clock. And Dr. Nagshetty Biradar sir, Principal BKIT, and Dr. Yatindra Kumar, Professor from the GB Pant University, uh, Pauri Gadwal, that falls in Uttarakhand, are going to deliver an excellent talk. So I request all the participants to join sharp at 10 o'clock in the morning and get the benefit of those research presentations. Just we are waiting for Dr. Nishant Jain to join. He is going to join within 1 or 2 minutes. And after the end of this 5 days FDP, the AICT Atal will send the feedback form. So to get your certificates, it is necessary to go to that site and fill up the feedback form. Apart from that, or whatever the regular feedback we are sending to you. After the end of this program, that is by tomorrow, they will send the link to all the participants. They will send the link, and you are requested to kindly fill up that feedback to get the certificates. हाँ निशांत ओके ओके हाँ ये ठीक है ना वो वेबकैम के लिए कुछ रिक्वायरमेंट नहीं है हाँ कोई रिक्वायरमेंट है डायरेक्टली यू कैन एक्टिवेट द लिंक सर हाँ take 5 minutes. I will request the participants to take the break. Okay. Dear participants, sorry for some inconvenience network problem. I request all the participants to join after 10 minutes. You take the break for 10 minutes and join at 12:35, please.
Hello. 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 Okay. Sir, am I audible?
Yeah. Just one minute. I will cut
Okay.
this phone. Okay.
Okay. Okay, sir. Hello. Am I audible? Hello. यहाँ कैमरा भी तो था ना यार? यहाँ नहीं था। अच्छा। यहाँ पर वाईफाई चलता है? अच्छा। एक मिनट वो लैपटॉप उठा दो मेरा। हेलो। हेलो। हाँ। हेलो। हाँ सर, एम आई
हाँ
ऑडिबल? हाँ
हाँ
सर,
बोलिए।
आपकी आवाज आ रही है सर।
आवाज तो आ रहा है लेकिन आपका पिक्चर नहीं आ रहा है। डेस्कटॉप से कर रहे हैं या लैपटॉप से?
हाँ सर, मैं डेस्कटॉप से ही कर रहा हूँ।
ओके
लैपटॉप
वो
से मैं ट्राई करता हूँ, ये वाला है।
कैमरा नहीं रहते ना उसमें।
हाँ सर, उसी का प्रॉब्लम है। एक बार लैपटॉप से भी ट्राई करता हूँ।
ओके एक मिनट निशांत वो एक दो पीपीटी दिखाओ।
हाँ सर, मैं एक मिनट।
वो भी नहीं होता ना कुछ क्या होता है?
पीपीटी हो जाएगी सर।
हाँ लेकिन आपका जो चेहरा है ना वो नहीं आ रहा है लेकिन
वो
नो
हाँ हाँ, वो वैसा हो
वो
जाएगा,
एक्चुअली हाँ वो
रोबोट
डेस्कटॉप
टाइप।
में वो कैमरा फिक्स करने का रहते ना वो थोड़ा।
बिल्कुल।
ओके
मैं
ओके ओके नो
एक बार
प्रॉब्लम।
शेयर कंप्यूटर साउंड। आई गेस माय पीपीटी
We
इज
got
विजिबल।
your PPT
हाँ
displayed here.
जी, मैं एक बार वो करके देखता हूँ, अगर मेरा चल जाता है ना
हाँ देखो
लैपटॉप से।
ओके देखो।
यही वाला है ना वाईफाई कनेक्ट? सर कर लिया सर, कर लिया। है क्यों नहीं रहा है ये? ये करता हूँ, इसका नेटवर्क थोड़ा तेज है। अच्छा, ईसीएल तो नीचे वाली होगी ना? ये तो रिफ्रेश करने की जरूरत नहीं पड़ेगी, है ना? लो, जब मैं दूसरा डालता हूँ वहाँ का 26 इसमें ना लैन ही नहीं है एक्चुअली। मेन यही वो हो गया, ये अभी लिया था ना मैंने, तो मुझे लगा था लैन तो होगा। हाँ नहीं, अब इसमें चल जाएगा। ये click launch button. डाउन, अच्छा ठीक है। सर लैपटॉप में जस्ट 2-3 मिनट लगे, इट विल टेक 2 or 3 more minutes.
Otherwise, Nishant, otherwise, if you don't want to show your picture, you can start the presentation, no problem. Presentation, there is no problem as far as the presentation is concerned, but the only thing is that you are not visible.
Right, sir. So it is almost done. Just
Okay, no problem, no problem. Okay, done. Now you are visible.
Now I am connected with two systems, so 1 minute कर देता हूँ shutdown.
Yes, Nishant, you are now visible.
Yes.
इसमें से आ जाएगा, ऐसे ही ओपन हो गया, कोई प्रॉब्लम नहीं। करना चाहते कर सकते हैं, नहीं कोई प्रॉब्लम नहीं है, ऐसे ही रहना। ठीक है, थैंक यू।
Nishant, now it is audible to you.
Yes sir, you are audible. Am I audible?
Yeah, you are audible. Your PPTs are also audible. Now I welcome you to this presentation. Before that, I request all the participants to have your brief introduction. I request my research scholar Sweta to introduce you in brief.
Good afternoon, sir, and welcome to Nishant, sir. And sir, brief introductions. Sir has completed in MTech in Instrumentation Science Signal Processing from IIT Roorkee in 2012. And in 2012, sir has received PhD from IIT Roorkee in area of medical image processing. Presently, sir is working as assistant professor at JP University of Information Technology, Solan, Himachal Pradesh. Sir research interest includes image processing, machine learning, and IoT. And sir got publication in SCI journals, and currently sir is guiding 3 research scholars and who are working in this area of medical image processing and hyperspectral images. Sir has given a talk in many FDPs and workshops in his career. And he is member of Center of Excellence in Healthcare Technologies and Informatics and Technology Incubations and Entrepreneurship Development Cell at his universities. And thank you, sirs. And I request to deliver your expert lectures.
Okay, thank you so much for the introduction. So, good afternoon to everyone, all the participants. So, in for this presentation, like I am going to present on the application of artificial intelligence on medical images. So, to start with the presentation, first of all, I will try to make you realize that how human visual system works and how our intelligence help us to make decision, and then I will uh, introduce artificial intelligence. What is the purpose of artificial intelligence and how it helps to mimic the human brain. After that, we are going to discuss different medical imaging modality, because my topic is concentrating on the medical imaging side. So I am going to just introduce you how we are able to get different images, medical images, and the concept is same. So, and then we are going to discuss different applications of AI in medical image, and the applications will be image classification, enhancement, segmentation, and registration. So, starting with the human visual system and intelligence. So, first of all, I just want to know, could you identify the following alphabet? Like this one, it is quite simple. Like everyone can guess, it is T. But what about this one? Is it J or it is T? So since the font style is somewhat stylish, so some people they got confused, and we like for this particular case, everyone will be 100% sure that this alphabet it is T. But when people come across this font, then whatever we are going to say, even if we are saying that it is T, but there must be some probability. We might have some confusion in our brain. Like we may say that 80% it looks like a T, but there is some chance that it may be J also, because in some stylish style fonts, this J can also be represented somewhat like this. So in actual, these both are T. And uh, just a minute. These both are T, and this one it is the Arial font, and this is our Pinion script font that is available in our MS Word or this Google slides. So both are T, but when we make a decision for this one, then there is probability come into picture. We are not 100% sure that whether it is T or J. Now the next one. Over here, one alphabet is embedded in this texture. So could you identify that? So since most of the people they will be able to guess that it is A, but what about this one? Now when I show this picture to my students and in different like workshops, so when people saw this picture, at the very first instance they come to the conclusion that it is V. But after some time, when they keep on seeing this picture, then they realize there is one horizontal line also embedded in this texture. And then they immediately change their answer and they say that it is A, inverted A. Okay, so why I put this picture over here is just to show you that in the previous picture, because we know that in our brain the template for A is like this, that there is a two horizontal line, two slant lines are there which are interconnected at the top, whereas for V there are two slant lines interconnected at the bottom. So when we see this type of an image, immediately, because seeing these two slant lines, we come to the conclusion that it is V. But after some time, when we keep on seeing this picture, then we also realize that there is a horizontal line. And then again, our brain says to us that since A, A contains two slant lines joined at a common point and a one horizontal line. So immediately we change our answer. Okay, so whatever time we are taking, like we guess this picture within no time. As soon as this picture is shown, immediately we can come to the conclusion that it is T. But when this picture, this character is shown to us, then we need at least some milliseconds. We need to think, we need to relate the texture, whether this can be considered as a horizontal line, whether this can be considered as a vertical line. So we need to make a decision, and to make a decision we just try to localize. First of all, we try to localize the position of this, and then after localizing we try to just match with the template that is stored in our brain, template for different characters, alphabets. And then we, inside our brain, we make the probabilities to make the judgments. Okay, so if it looks like a horizontal line, we take a probability that it looks like a horizontal line, so 80% chance is there for say. And it looks like a vertical line, but there is also a curve. So this curve may confuse us and may tend us to say that it may be J also. So we need to take some time, whereas we do not need to take any time when we see this particular image. Similarly, when this image is shown, immediately because of this part, there is no other font which has this type of thing. So immediately we come to the decision that it is A. And when this picture is shown, because this is a style of V, so immediately we come to the decision that it is V. But after seeing this horizontal line, we change our, most of the people, they change the answer and say that it is A. So overall, what I want to say is that whenever we see anything, if the picture is clear, that there is no confusion, so we come to the conclusion immediately. But if the picture is somewhat complex, then we need some time. And that time is taken just to compare the given texture or given image with the image of the object that is present in our brain. So we just try to compare with all the objects, image of all the objects that is present in our brain. We try to compare, and we make a decision for which the probability is the maximum. Okay, so if we try to formulate this in block diagram form, then then we can simply, whatever steps we take to just analyze the object or the image to make a decision what type of a object it is. Basically, we can divide these steps into these four steps. First of all, we capture the image with the help of our eyes. So our eye, it captured the image. Once the image is captured, this captured image, it is sent to the brain. And inside the brain, we locate the desired object. Locate the desired object, it means that we identify the position of this character. We identify the position of this black color. And after locating the position of this black color, then we try to get some features. Features in the sense that whether it is a horizontal line or a slant line or what it is, can be with how much probability we can consider it as a horizontal line, with how much probability we can consider it as a vertical line. So this type of features we try to extract in our brain. So after locating the object, we try to extract the features. And after extracting the features, with the help of these features, we try to compare with the information that is already stored in our brain, already stored With already stored, I mean the information that we keep on storing right from our childhood. The information that we keep on storing, we just compare the extracted features with the already stored information, and then and then accordingly we make a decision. And even if after making a decision, if we have some confusion, is then sometimes we make a decision in a probabilistic terms. Like sometimes we used to say that it looks like there is 60% chance that the object is this, but still it may be this also. So I am not that much sure. So when we are not sure, sometimes we make statements in a probability form. So now this human intelligence can also be like, we can include this also, image enhancement also in this block diagram. In the previous block diagram, we can include this image enhancement also. And the purpose of this image enhancement is, like sometimes you must have feel, suppose you draw a needle is dropped on the floor, and if we are trying to see, if we are trying to find the needle that falls on the floor, if we try to find the needle from the top view, so it sometimes it is not that much visible. But some people, what they do, they try to see the needle from the side view. They try to have a side view of the needle. So they just lie down on the floor and try to see the needle from the side view. And the purpose of seeing the needle from the side view is that because needle is a three-dimensional object. So if the person try to see the object from the side view, then some height will be there. So because of that height, it becomes easy to identify, locate to locate that there is some object on the floor, because our floor is completely smooth, horizontal surface is there. So if something is coming out of the surface, then immediately we can find it. But if we see the object from the top view, then that the height of the object will not be visible to us. So that type of a processing comes under the category of image enhancement. So overall, whenever we see any object, then we have to follow this step. Usually we follow these steps. Sometimes we do not need, like sometimes we do not need image enhancement methods. Sometimes we do not need segmentation also. Okay, so some steps sometimes we may miss, but most of the time we have to follow all the steps. So this is our human vision visual system and the intelligence with which we make a decision. After that, coming to the artificial intelligence. Now the main purpose of this artificial intelligence is just to mimic the human intelligence. Whatever intelligence we have, we just want to mimic that with the help of some softwares, so that our computer, our robot can think exactly in the same way as humans do. So that they may have at least exactly same intelligence which humans have. And like these days, like previously emotions were not there, but this time, these days, emotions are also coming into the picture. So the way we have the emotions, computers also starting having the emotions. So the main purpose of the artificial intelligence is to mimic the human being, intelligence of the human being, and to make machine analyze the task given and take decision in the same way as humans can do. Now, this artificial intelligence, usually like these are related terms, artificial intelligence, machine learning, deep learning, and like this, most of the time they are quite confusing term, because if we look at the textbooks of this, most of the syllabus or the contents we find that they are very much similar. Then why the three terms are required? Are they really same or they are different? So as you can see in this particular diagram, that this deep learning part, it is the subset of machine learning. Means whatever methods are there in this deep learning, they are also part of machine learning. But some methods that are available in machine learning, they are not the part of deep learning. Okay. Similarly, everything that is there in this machine learning is the part of artificial intelligence. But everything that is there in the artificial intelligence is not the part of machine learning. So what is artificial intelligence? So it is any technique that enables computers to mimic human intelligence using any logic, or if then rules, decision tree, anything, any mathematical equations. So if we are able to mimic the humans by any method, then that comes under the category of artificial intelligence. Whereas machine learning, machine learning involves all the methods in which we try to train our machine by giving some inputs and output also. And by giving the input and output combination, which we usually say training data set. So by giving the training data set, machine on itself try to try to learn from the input and the output. It is something like we used to teach small kids, like when we were small, when we want to, like when teacher told us about the alphabets A B C D, so we were told like this, we were shown the picture of A, and teacher used to tell us that it is A. So in this way we make a learning different style of the A character we used to see since our childhood. So different in different with different images, we our brain got trained. So in machine learning we used to give some inputs and the output also, and with the help of input and the output, machine learn itself, so that machine will be able, after got trained, machine will be able to predict or will be able to make a decision when some new data is given to the machine. Okay. And this deep learning, when we involves this multi-layered neural network, when this training of the machine, when the training of the machine is done with the help of the neurons, artificial neurons, then it comes under the category of deep learning. Okay, so artificial intelligence is any program, any logic, any if then else condition, anything that helps in mimic the human intelligence comes under the category of artificial intelligence. Machine learning, if input and output is given and asked computer is training itself on its own, then that is machine learning. If for training of the machine, if we are using neural network, then it comes under the category of deep learning. So now coming to the major applications of AI on medical images. So these are some of the major applications: classification, image enhancement, segmentation of desired objects, segmentation, image registration, and image fusion. So in image fusion, uh, in for this presentation, I am going to discuss only these four, because image fusion is something like modalities, how we are able to scan how we are able to have the different scans like x-ray, mri, and other things. We also know that we are not able to see x-rays are invisible, mri is invisible, ultrasound is invisible, but still we are able to create an image from the invisible rays, and that images helps doctor to diagnose the patient. So how the images are acquired? So just a brief introduction to that. Now in any digital camera, we have a sensor that include one sensor followed by a ADC, analog to digital converter. This sensor, it sends the input energy. This input energy, it can be anything. It can be visible light, it can be any energy, any energy that falls in electromagnetic radiation or in sound waves. So it all depends on this particular sensor, that how sensitive this sensor is for the particular energy. If this sensor is sensitive for the visible light, then this sensor will be able to capture the visible light. If this sensor is sensitive to x-rays, then if x-ray fall on this sensor, then this sensor will get activated and accordingly some voltage signal will be generated. If MR radiation is there, then, and if sensor is able to capture or sense the MR radiation, then after capturing the MR radiation, it will give some analog voltage signal. So the amount of energy this sensor is going to sense, the voltage signal will be according to that. And since we are working in a digital computer, so everything like this sensor will give an analog output, but since we need to store it on computer, so we need to convert it into the digital form. So we use ADC. So this ADC will help us to convert this analog voltage signal into the digital value. So this complete assembly, it forms a pixel, just a single pixel. Now, if we arrange this assembly in this array form, then we are able to get a 2D image, two-dimensional image, something like this. And each square can have only a single value because each square is nothing but the assembly of this sensor and ADC. So each square can have only a single value, but the group of these sensors, when arranged in an array, in two-dimensional array, it helps us to capture the image. So depending on the energy, depending on this input energy, we will be able to get the output image. If the energy is visible, if this energy is visible rays, then the image that we are able to get, it will be the exactly the same image that we used to see with our eyes. But if this input energy, or if the sensor is able to sense only x-rays, then if this input energy is x-ray, then the image will be x-ray. So capturing process is almost same with some parameter change, but main concept is this only. And after this, we are able to capture to form different images, and all these images are the images which our eyes are not able to see. This is the CT, this is the X-ray image, this is CT image, this is MRI image, this is ultrasound image, and this is thermal imaging, thermal image. Okay. So concept is same, only changes in the sensor. Capability of this sensor to sense the particular energy will help us to form the image, corresponding image. And this different imaging modalities helps us to detect different body organ, different information of the body organ. For example, X-rays, they are used to image the structure of the body organs, especially bones. Whenever doctor needs the information of the bones, doctors just recommend X-ray. CT, it uses series of X-rays to create cross-section image of the body organ. So CT is nothing but a three-dimensional form of X-ray. Three-dimensional means that interior of the organ is also visible in this CT. MRI, it uses magnetic field and radio waves to scan the information of soft tissue in the body organ. So X-rays, these bones are the are hard tissues. So X-rays are able to scan clearly all the hard tissues, whereas MRI, they are able to scan soft tissues in the body organ. Ultrasound, it uses high frequency sound waves to image body organs. And like this ultrasound, it is not able to scan like skull of the human being, but it is able, like whenever we need to scan something for the liver or anything in our stomach area. So ultrasound is preferred, and the purpose, because till date there is no side effect, non-side effects is, there is no non-side effects available for ultrasound imaging. So ultrasound imaging, it is the safest one, and it is the reason that when lady is pregnant and fetus is there inside the body, so only ultrasound is preferred, because there is no side effects for this, there is no radiation, no ionization. So uh, by using ultrasound, there will be no problem, no effects will be there to the fetus inside the body. Then positron emission tomography. So this, it uses radioactive drugs to scan the functioning of the tissues. So whether the organ is how the organ is functioning, that can be detected with the help of a PET. So different imaging modality, with the help of different imaging modality, doctors are able to scan human body for different organs, for different tissues, for different functioning. And since, as you can see, all the images, they have different, like over here in the CT, this is the bone area, which is completely white. Whereas interior part is it is the soft tissues. In MRI, these soft tissues, they have some textures, and means MRI is able to scan the soft tissues clearly, whereas information is lost in CT. CT is not able to scan the soft tissues properly, whereas in MRI, the information of bone is lost, because MRI is not able to scan bone or hard tissues effectively, whereas CT can do. So the information in CT and the information in MRI, they are somewhat contrast. So the information, if doctor wants to have the information of the bone structure, then CT is preferred. If doctor want to have the information of the soft tissue, then MRI is preferred. And ultrasound, it is preferred because there is no side effects, it is economical, portable, and different good parameters are there with respect to ultrasound. Only problem with the ultrasound is that, like when anyone see this type of an image, so common person can also come to the conclusion that it is the image of the brain. But when we see the ultrasound images, it looks same, irrespective of the organ for which ultrasound is taken. Still all the ultrasound images, they look same. So so for the doctors also, like it is quite easy to determine or to diagnose the body using this type of imaging in comparison to ultrasound. But since ultrasound does not have any side effects, so it is the most preferred one, and research is going on to use ultrasound for different body organs. So coming to the application part of AI on artificial intelligence. The first application is classification. Now for classification, traditional approach is this, that first we extract some features from the image. First we extract some features from the image, and then out of that features we try to select the most important one, or we try to unselect all the irrelevant features that we extracted in the first step. So, and after selecting the best features or the relevant features, then we go for the classification to classify whether to classify the category of the object. So what is this feature extraction? With feature extraction, I simply mean that whatever object we are seeing, if we want to use computer to make the analysis, to make a decision, then since computer is a machine that works on binary numbers or that works on numbers, so whatever information that is visible to us, like when we see this type of surfaces, and if someone asked us to conclude about the roughness of these surfaces, then seeing this particular image we can see that it is the smoothest one. The roughness is the minimum for this image in comparison to all the others, whereas the roughness of the surface is maximum for this one. So this we can see when we see these surfaces, we make a decision. But if we want computer to make a decision, then since computer can understand only numbers, so somehow we need to convert this visual information into the quantitative values, so that with the help of that quantitative values, computer can make decision. So that quantitative values should be search that make a that helps computer to make a classification. For example, like these values that is there in on these images, they are the standard deviation of the pixel values. So I just calculated the standard deviation of all these images, all these surfaces, and I found that the standard deviation for this particular image it is 5.88. Second image 9.74, 12.79, 20.54, 23.85, 21.79, 26.46, and 38.56. And from the numbers, you can see that whatever visual information we are getting, like we know, we from the by seeing this particular surface, we know that it is the smoothest of all. The roughness is minimum for in this, whereas roughness is maximum in this. And if we see the standard deviation, if we relate the standard deviation with the roughness, we can see that standard deviation is also increasing with the roughness. It is minimum for the smoothest, it is maximum for the that has the high roughness. So we can take this standard deviation as a feature that will help machine to make a decision about the roughness of the surface. Means if I just give this type of a pattern, this type of numbers to the, if I give these numbers as an input to the machine, at the same time, if I inform the machine, if I give another input to the machine, which is that if the number is 5.88, if it is near to 0, then the surface is smooth. And if it is at the higher side, then it is the rough. So computer can make a prediction. Just seeing the value, computer can make a prediction whether the surface is smooth or rough. So even if I give this as an input to the machine, then computer will first determine the value of this standard deviation from the image pixels. Computer will first determine the feature which is standard deviation, and after getting that feature, computer will relate from the previous knowledge which we have already given to the computer. From that knowledge, computer will categorize the surface as smooth or rough. Okay, so this is the feature help us to convert the visual, or to help us to convert the image into the quantitative value, and that quantitative value will help computer to make a decision. We have large number of feature extraction techniques available in literature. Some of the most common texture features are this. After feature extraction, next step is feature selection. With feature selection, we try to remove all the irrelevant and redundant features. Now, what I mean with this? with, first of all, irrelevant features. With irrelevant features, I mean to say, suppose if we want to classify whether the given object is a chair or a table. Now, if we want to classify between chair and table, then color information is not at all relevant. We cannot classify between chair and table on the basis of color, right? So, if we consider that color as a feature, if we consider color as a feature, then that information, that feature will just misguide us. Misguide in the sense, for example, suppose if we are teaching a small child whether the object is a chair or a table, and if it happens by chance that all the chairs that we show to the kid, if it happens like by chance, if all the chairs are of the same color, say brown color, then child may take a may train child may get a training may, a child may put a impression in his brain that he can classify the chair on the basis of color also, because whatever chairs that are shown to the kid, if all the chairs have the same color, then on the basis of the color, child will feel that all the chairs, they are always of brown color. So it will just mislead the child. So it is our duty that we should, like if we are teaching any kid, it is the duty of the instructor to tell the child that color is not relevant. So we should remove that feature from the brain of the child by just asking him or instructing him that color is not the important parameter. In the same way, we need to analyze all the features that we extracted in the first steps. We need to analyze if there exists some feature value that is irrelevant, in the sense that that does not helps in predicting the category of the object. So that we need to remove by using feature selection methods. Second thing is redundant features. Redundant, as the term says, that features, if we have two features that are giving same information, means if we plot the two features on a graph, then if the two, like if we increase the, if one feature is increasing, second feature is also increasing. If one feature is decreasing, second feature is also decreasing with the same gradient or slope, then it means that the two features, they are exactly same. Two feature values, they are exactly same. So it is always better to use only one feature. If we have more than one features that are giving same information means that the feature is changing at the equal, with the equal rate. If more than one features are changing with the equal rate, then it is better to use only a single feature, so that computer complexity may be reduced uh, for the computer, so that computer may not get confused with a large number of features available, and we may be able to provide only the relevant and non-redundant features to this computer, so that computer can try to train itself only with respect to these selected features. After feature selection, next task is the classification. Now with classification, if we talk just the simplest classification, then suppose if we have two features, one is mean, another is standard deviation, then, and if we plot it in a 2D graph, and suppose if this green one, they are one category of objects, this red one, they are second category of object, then to classify, to, to categorize this into one unit, this red one into another unit, it is better like if we somehow able to draw this boundary. If somehow we are able to draw this boundary, then then we can say that anything, after extracting these two features, if the point is located on this green area, then this we will categorize that object as with this one. And if the coordinate of this falls in this red region, then the object will be categorized into this region. So somehow we need to get this boundary. Okay, somehow we need to get the equation of this boundary. And with equation of this boundary, since it is a 2D graph, only two features are there, x0 and x1. So linear equation will be there for this particular line. And the equation, it may be something like w0 x0, w1 x1 plus w2 equals to 0. Whereas x0 and x1, they are these features, whereas w0, w1, w2, they are the weights given to these features. W0 is the weight given to the feature x0, w1 is the weight assigned to x1, w2 is the weight assigned to bias. So just with the help of the classification methods, in classification methods, we just try to identify, we just try to get the value of this W0, W1, W2. Means we try to get the value of the coefficients of this features. So whatever features we selected in the second step, we try to make a equation, linear equation. And to get the linear equation, we just need to determine the value of these W's, weights for different parameters. And the weight should be such that if the point is located on this particular line, if all the points that are located on this particular line, if we substitute that values x0, x1 in this equation, then it will give you 0. If it gives you greater than 0, then the object will be categorized into this category. If it is less than 0, then object will be categorized into this one. So overall, we start with feature extraction. Means we start with by extracting mean and standard deviation for this particular example. After that, with the help of some input and output combination, with the help of some training data set, we are able to get the coefficients or the weights value of this. And once we get this, just for any testing data, just we need to evaluate, we need to determine the value of x0 and x1. After determining the value of x0, x1, we will just substitute these values in this equation. And after substituting, if we are getting greater than 0, then we will make a decision, computer will make a decision that the category of the object is this green area. But if after substitution, if it comes out to be less than 0, then computer will make a decision that the object belongs to this red region. So it is quite simple. Only thing is, whatever visual information we have, we first quantify it. After quantifying it, we remove irrelevant and redundant feature. And after removing that, we just try to form the equation for the decision boundary, so that anything that falls above it will be, after substitution, will give you greater than 0 or less than 0, so that we can categorize the input image into any of these two categories. So this is the simplest classification that uses only a single neuron. This is a neuron, this complete set. This neuron, it is the artificial neuron that mimics the behavior of the neurons that we have in our brain. So after this equation can be represented in this form, like x1 w1 x plus x2 w2 plus xi wi plus xn wn plus wn plus 1. So this summation will help you to form this equation. up to W2. After that, we have the activation element. With the help of this activation element, we will be able to get the value either +1 or -1. If the value for this equation, if it is greater than 0, then it will give you answer +1. If the value is less than 0, then it will give you -1. So by the end of this activation element, your answer will always be either +1 or -1. That is, +1 means it is greater than 0, means it will be categorized into this green area. And -1, if it is -1, then it means less than 0. So the object will be categorized into this red region. And this W, how we are able to update, how we are able to get the value of this W. To get the value of this W, we have this type of formulas. This is the updated weight equals to previous weight plus learning rate into previous output into input, जो कि हमने input दिया, the input that we have given. And with the help of this equation, we will be able to train our system somewhat in this way. Like when we initialize the weight randomly, suppose we initialize the weight as 0 and 1, then the boundary will be represented with this black line. Boundary is represented with this black line. After first iteration, means after first correction, when we are going to update the weights after first correction, then this boundary, it shifts to this region. After this, you can see still there is one misclassified object, because this blue boundary should be, our boundary should be somewhat like this, because red regions are over here, blue is over here. So our boundary should divide, should classify or categorize this into one unit and this into another. So our boundary should be somewhat like this. When we select the boundary randomly, in the starting, when we select the boundary like this, then we can see that it is not able to classify or categorize the object. This one should be on this side, but it is misclassified. So since it is misclassified, so we update this weight by using this formula. So by updating the weight, we are able to get the boundary at this location. But still we can see that still it is not classified properly. So again we update the weight, and you can see that previously boundary is this. Now the boundary is over here after second update. And after second update, you can see that our decision boundary, on one side we have this blue objects, on second side we have this red object. So after second correction, we are able to form a decision boundary that helps us to categorize the two objects. So this is the way this classification works. So with the help of this traditional method, in which we first extract the feature, then we select the features, then we classify the features, we can categorize, we can classify the image. So for medical images, if we give some, like if we want to classify between the normal and the abnormal cases, then simply, first of all, we need to extract the features from the normal as well as abnormal cases, and then that features will be given as input to the classifier to predict the class of the input image, whether it is normal or abnormal. So are the steps. After this traditional method, these days the most common method is convolutional neural network. In convolutional neural network, if you see that in convolutional neural network, whatever we were doing in a traditional, by following the traditional method, In CNN, convolutional neural network, we have just fully automated. Means over here, we do not need to identify the features. We do not need to extract the features from the image. Means feature extraction method, separate feature extraction method is not there. Separate feature selection methods are also not required. Everything is embedded into a single platform, and all the weights at in convolutional layer, weights in this fully connected, all are going to be trained according to the input image and the desired output. So in this CNN, we just have to provide this CNN with the input image and the desired output. And then system or computer or this neural network, CNN, it is going to train this convolutional layer, pooling, fully connected layer, all the weights present, weights on this. It is going to train all of them. After training, if we are going to provide any input image over here in the input of this CNN, then we will be able to get the desired output. Okay, so let us just in brief, let me explain what is this convolutional layer. Convolution, like in image segmentation, in image processing with convolution, we mean that if this is our image, if this is our filter, then we just put this filter on this image in such a way that this complete filter should see, first of all, we are going to put it over here such that this center element, it will overlap with this. In this portion of the image, it will be overlapped with the filter, and after that, we are just going to multiply pix element by element. Means this 0 into 1, this 1 into 0 plus 1 into 1. We multiply element by element, all the overlapping elements we multiply, and then we add them all to get the value of the output image. For example, over here, when this red one and this one during convolution, when we are over here, when we are over here, then after multiplying and adding the values, we are able to get 4. Once we are able to get 4, then we shift this filter by one position towards right. Means then it will be over here. And after placing it over here, we will be able to get the value of this. Once we are able to get the output value for this row, then we are going to shift this filter by one position towards down, means towards bottom side. And again, we are going to do the convolution. First for this one, then we shift by one position towards right, and we just follow this pattern for the complete image to form this image, final image. So in convolution, this will be the filter. We need to decide when we are designing, uh, when we are designing the CNN, we need to mention that how many layers should be there in the convolutional layer. Just we need to define the number of layers. We do not need to define this numbers 101 or what number it is. This will be the random weights which will get trained, which will get trained with the input image and the output image on its own. Means just with the input information, input training data set, this numbers will be generated, or will be these weights will be assigned by the CNN itself. And it is the reason that in CNN we just have to declare, our task is just to declare the number of layers. Apart from that, we do not need to do anything else. So this is CNN. Now after CNN, we have this ReLU. It is rectified linear unit. Short form is ReLU. And it is the means if the output value, like if the output value of this convolution layer, if the value is less than 0, then everything will get 0. But if the value is greater than 0, then it will be y equals to x. So if the output of the convolution layer, if it is less than 0, then all the negative values will be converted to 0. But if the value is greater than 0, then the value remain as it is. So the function of it is the function of rectified linear unit. So each convolution layer, just after the convolution, we have to perform this ReLU operation. And this ReLU operation, it is one type of activation. We can have another type of activations also. So depending on us, then when we configure this CNN, then what activation function we have decided. Accordingly, we will get the output of the convolution plus ReLU layer. After this convolution plus ReLU, we have a pooling. With pooling, we are able to downsample or reduce the size of the object of the image. How this pooling works? We have different type of pooling operations. If we consider this max pool, then with max pool, we just form a combination. We just form a group of 4 pixels like this. This is one group, this is another group, third group, and fourth group. And in all the groups, we will just select the value which has the highest value. Like in this blue one, highest value is 9. So we select 9. In green, highest value is 7. So we select 7. In yellow, highest value is 8. So we select 8. In this red one, the highest value is, it is 6. It is hidden in, it is 6. So we put 6. So with the help of pooling, we are able to downsample the image and reduce the size of the matrix. So after the convolution and the ReLU, we have to, in CNN, we have to perform this pooling operation. Once we reduce the size, again we can have the convolution layers. And again we can have pooling operation. So we can have any number of convolution layer followed by pooling, followed by convolution layer, depending on our depending on the way we want to configure our CNN. So just we need to mention, like if we are using some MATLAB toolboxes related to deep learning or some Python toolboxes related to deep learning, then over there we just have to mention the number of layers, convolutional layers, and the size of the filter that we want to use. And all the other things, like what will be the weights, what will be the weights of this convolution layer filter, it will be decided by the training of the CNN. So we do not need to worry about the weights. After the pooling, after the last pooling, then we have a fully connected regions. Fully connected region layers, they are somewhat like this. Somewhat like this means they are almost same as we have in a traditional method. Like in the traditional method, we have this convolution layer, this classification step as a third step. So this third step, we have neurons. So similarly, in this CNN, when we are at this fully connected layer, then we can have this type of configuration, and each of this circle, it represents individual neuron, artificial neuron. So with the help of these fully connected neurons or layers, we are able to predict the probability to the different objects. So for example, over here, this system, it is shown that this system has given the value 0.95 to dog, 0.05 to cat. So since this is higher than this, so we can decide that we can declare, or the CNN can declare that the given image is of the dog. So by in CNN, we just, everything is like automated in the sense that we just have to declare the number of convolution layer, we just have to declare the number of fully connected layers, we have to declare the ReLU function, activation function, we have to declare the pooling function, max function, use whether we want to use max pool or min pool or any other pool, that these things we need to define. And after that, only task that is left is to give the training input image data set. And after giving the training data set, system CNN will get trained itself in such a way that when we give some new data set, new images to CNN, CNN will be able to classify the object. So there are large number of CNN networks. If you go through the research paper, you will be able to find lot of research paper these days that are on this CNN networks only. And there are some networks from like we have LXNet, ZFNet, GoogleNet. So there are some networks that are trained with billions of images, and these images, so these networks, they are highly trained. And in most of the cases, like if we put the of any input image as an input to this image, to this CNN, then there is a high chance that we get the output. And this networks, they are available freely. Means freely in the sense that if you are using Python, they are available free. If you are using MATLAB, then you need to get the subscription for the deep learning toolbox, and then it will be available for use. For use means that we can use this network to for our data set, and we can try to get the result. We can try to check whether this network, which are trained with large number of input images with different types of categories of images, are they possible to give some are they able to classify the images that we have in our data set. That images may be of medical image or anything. Okay, like these days, because like in medical images, most of the time, like we do not have huge data set that is required to train CNN. So sometimes we try to use the already trained network like this, which are trained with a large number of images. We try to use this network for the images, for the medical images that we have, and we try to get some results, in the sense that if we are getting some positive results, then we can use this particular network along with some other additional layers to get the results of highly accurate results for our data set. So this is known as transfer learning, that we are transferring the learning of this network to the to our data set. So this is image classification. Now after image classification, coming to the next application, which is image enhancement. So image enhancement methods, they are used for the following two purposes. First purpose of image enhancement is to improve the visual perception, and the second is to prepare the image for improving the subsequent tasks like segmentation, classification, etc. more effectively. now what I mean by this, to improve the visual perception, to check that, like this Chen, he has presented a paper in this conference CVPR in 2018, and he has presented a beautiful results. Let me show you. You can see that this is the input image and this is the output enhanced image, and you can see the difference between the two in terms of visual perception. So with the help of neural network, CNN network, researcher is able to enhance the image, and the purpose is to increase the visual quality. But apart from this visual quality, apart from this visual quality, image enhancement, it is also done to increase the size of the image. Like over here, using deep learning, we can train a neural network to zoom in the image at 2x or even 4x ratio, making it possible to enhance the quality of a low resolution image. Means, like most of the time when we zoom in the image, most of the time we feel that the image got blurred, right? But with the help of these deep learning algorithms, we can implement these algorithms on the image so that we can we can increase the size of the image by including more pixels onto the image, and the quality of the image will be get increased. Over here, like this is the image that I found, that is obtained from this image IBM Max Image Resolution Enhancer, and this deployable model allow user to upscale an image by a factor of 4. Means whatever is the size of this image, it is increased 4 times. So that, like usually when we zoom in the image got blurred, but with the help of deep learning algorithms, we are able to enhance the image. So that is the beauty of this deep learning algorithms or AI. We can use image enhancement to increase the to enhance the medical images. And this image, like in the over here I mentioned that we use image enhancement for two purpose. It purpose may be to improve the visual perception of the image, purpose may be to improve the image for to prepare the image for improving this subsequent task, like segmentation, classification, etc., more effectively. Means suppose like over here, if this is the image, if we want to segment the image, then since this texture is there is a grayish shade over here, so compared to this, like if we see the contrast, it is complete black, it is almost black, it is quite white. So contrast, or contrast, with contrast I mean difference between the pixels. Over here pixel intensity value is high, over here pixel intensity value is low, so the difference is high, whereas over here difference is low. Due to this low difference, image segmentation methods will not be able to perform that effectively for this particular image, as the same method will be able to produce the result after image enhancement. So image enhancement method helps us to prepare the image for the subsequent methods. Like for the subsequent methods, it may be like image segmentation. So if we are trying to perform image segmentation, it is better if we first enhance the image so that we prepare the image for this image segmentation method, so that image segmentation method may produce the result more effectively. So after image enhancement, next application for AI is image segmentation. Now with image segmentation, our task is just, if we have this type of image and we want to segment out, or we want to extract the desired object from the image. So that is the part. that is image segmentation. So image segmentation, basically it is a method that divides an image into segment to simplify image analysis. Each segment represents object or part of the object. Pixel in each segment is somehow related to each other on the basis of which pixels are grouped in the element. Means, like you can see that all the pixels that are there inside it, they are of black shade. Means the value, intensity value is quite less in comparison to the outer area. So we need to have some similarity in the segmentation. Okay? And with the help of that similarity, we are able to extract, we are able to segment the objects. From medical images, it extracts clinical relevant information. With this, I mean that since it is a tumor region, so if I am able to segment this region, then I will be able to help the doctor in, means doctor does not have to worry and does not have to diagnose for the location of this object. I can, with the help of my software, I can help doctor in predicting, in segmenting, in locating the abnormal area. So for image segmentation, different methods are available. Thresholding methods are there, histogram methods are there, clustering methods are there, edge detection, and image segmentation with CNNs. So since I am very close to time, so let me cover it in brief. So with thresholding, I means that suppose if this is my input image, so since the white area, they are given a high pixel value. So suppose since it is a binary image, so if the background is 1, this T, it is black, so it is 0. So just we can see that this, if we just locate the position of the 0, then we will be able to segment the object. So in thresholding, what we do is that if we have a grayscale image, then we just select a single pixel value in such a way that anything that goes beyond that pixel value or threshold value, then anything that goes beyond it, we will categorize it into the white region. Anything that is below that threshold value will be considered as black. So in that way, we are able to segment the desired objects. Similarly, like for image thresholding, we can also use histogram based method. In histogram method, like if this is our image, if we draw the histogram of this image, then image will be something, histogram will be something like this. Now if we select the threshold over here, say I select this 90, then if I select 90, then I am able to get this type of a result. Because from the histogram, I can see that there are two peaks. One is this region, and after that I have, this is second region. So if I want to convert, if I want to convert this image into the binary image, or if I want to segment this image, then simply if I select threshold value over here, then anything that is above it, means and pixel value greater than 80 will be taken as white, pixel value below 80 will be taken as black. So you can see this, it is a gray shade, but in the segmented image, it is visible as black. Then we have the clustering algorithms. In clustering algorithms, it is a method to partition an image into the number of disjoint groups or clusters. And we form the clusters by using some similarities. This similarity may be the similarity in the pixel intensity value. Means if in a cluster, if there is a group of pixels having the same pixel intensity, then we will group them into the same cluster. Most common clustering methods are k-mean and the fuzzy c-mean. They also come under the category of AI because, as I told you, AI, any mathematical equation comes under the category of AI. They consider pixel intensity value for determining the cluster set and do not consider the spatial relation between the pixels. So these clustering methods, they consider only the pixel intensity value and they do not consider what is there what is there near to in the nearby region. But the improved fuzzy C-mean methods, they can be improved fuzzy C-mean methods. They include this capability also, in which the method also, along with the similarity in the pixel value, it also tries to form a relation. It also tries to see the pixel values of the neighboring region, okay, and try to see how what is the distance between the two pixels. So spatial relation is also analyzed in some improved version of fuzzy C-mean method. Last, this edge detection based method are the method in which, first of all, we try to identify, we try to locate the edge of the object, like in this case. And after detecting the edges, then we try to identify the closed contour. If it is a closed contour, then everything, every pixel that is inside this closed contour, it will be considered as a object, an object. Now, after this, last application is image registration. Now, the purpose of image registration is demonstrated with the help of this images. Now, suppose purpose of image registration is used before combining the information of the two images to form a single image. What I mean from here is, suppose if I have two images, one is this, another is this, and if suppose if this image, like in our CT image, like over here, like I told you in the starting that this and this image, this is CT image, this is MRI image, these images, they are obtained for the same patient and from the same area of the skull. But you can see that the information over here and information over here, means information in the CT and the MR, they are both highly different from each other. Now, if doctor wants, if doctor wants both the information, then in the usual practice, doctor will ask the patient to scan, to get scan for both the modalities, and then doctor keep both these images parallelly and try to identify the location of this bone, identify the location of this bone with respect to the bone of this tumor with respect to the bone. So if with the help of image fusion, we just try to fuse this information into the single image, so that if the information is available in the single image, then doctor does not have to estimate. There will be no chance that doctor estimate it wrongly, because now the information of the bone and the information of the tumor are both at the same image. So it becomes easy for the doctor to predict the location of the bone that is near to the tumor. So by using this, but before the fusion of these two modalities, image registration is required, because if we do not register the image, with registration we means that this geometry orientation of both these images should be exactly same in the sense that if we keep this image, these two images one over the another, then the image that is at the bottom side, that image should not be visible, something like this. Over here, if this is one image, this obtained from one modality, this is another image obtained from another modality. Now, if I simply fuse these two images, then I will get this type of pattern. And you can see that there is some extra distortions are there or artifacts are there. Eyes are also not at the proper location, because the orientation of this and the orientation of this are different. So with image registration, before fusion, I will do image registration, and with image registration, I will try to orient this image in the same orientation as of this. So with image registration, after image registration, the orientation of both these images are same in such a way that now if I fuse these two images, then I get a proper image. having the information of the eyes as well as nose and the mouth, and that too without any distortion or artifacts. So this is image registration, requirement of image registration before image fusion. So as shown over here, like over here, if this is one modality, this is another modality, means CT, MRI. Now, if we fuse these two modalities as it is, then we will get output like this. But before fusion, if we just make this geometric alignment or orientation of these two modalities exactly the same, then this image will be rotated in anti-clockwise direction by say 45 degree. This image will be shifted towards top to over means over here, okay, slightly. Then after doing this, if I then fuse the image, then the obtained image will not be having any artifacts. So this is image registration. And for image registration, there are two approaches. First approach is a traditional approach in which first we try to identify the key point detection or feature description. Okay, these are the points like suppose if we have a suppose if we have if in the image like over here, if this is the image, okay, and we want to orient it in this direction, then we can try to identify the location of say major axis, minor axis for this, major axis and minor axis for this, and then we try to uh, 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 relate the major and the minor axis of this image and this image, and we try to identify the angle difference. Okay, if the size is different, then again by comparing the size of the major and the minor axis for both these images, we will be able to get the amount of resizing that we need to do. So with the help of some features, key point features, we are able to get how much orientation, by what angle we need to rotate one image, by what scale we need to zoom the image, and so on. So this is the traditional approach. And right now, like since CNN is there, so CNN is also able to get automatically, CNN is able to extract the features, and with the help of CNN we are able to orient or to align the geometric of both the images. It's just a minute please. So this is the deep learning approach. So this is all from my side. If you have any question, please ask me. So Sapna has asked how to select threshold value in the histogram equalization. Like as I told you that in histogram equalization, once we draw the histogram, even if after equalizing the histogram, we will get the final histogram somewhat like this only. So we just need to determine the location of the peaks, and we need to determine the location of the valley. And on the basis of, like, we have Otsu method, very common method that is available in literature. So with the help of Otsu method, we can apply after histogram equalization, we can apply Otsu method for the to determine the threshold value. Uh, any question from participants? How can we identify noise in an image using histogram? From the histogram, like for the image, like from the histogram, once we get the histogram, if we try to identify some features like standard deviation of this smoothness, like how the peaks are changing. So I guess with the help of that, we will be able to get the information of the noise from the histogram.
Thank you very much, Nishant. Uh,
Oh,
any questions from the participants? Please ask the queries. Just 1 minute, Nishant, be hold.
जी.
It is over. Just 1 minute,
Okay,
Nishant.
sir.
One question, sir.
Nishant, there is one question
Okay, sir.
from Shilpa Hiremat. Since the number of pixels in an image remains the same, I am getting the same histogram graph.
Okay. Actually, histogram, it depends on the pixel intensity value. So if the number of pixels, total number of pixels, if it remains same, then only difference will be that the only difference will be that total number. Means if you just take the cumulative frequency, cumulative of all graph curve will never if you have two images, and if you draw of the same size, and if you draw the histogram for both, then there is no chance that you will get the exactly the same histogram. Histogram will be exactly same only if the pixel intensity values in the two images are exactly same. If there is any variation, then there is no chance that you will get the histogram, same histogram for the two images.
If the queries are over, I think I am very thankful to Dr. Nishant for your clear crystal, a very nice presentation and discussion on image from image acquisition, classification, restoration, and segmentation, and finally to expose the participants to the deep learning and artificial intelligence level. Thank you very much for your excellent, really excellent presentation on this occasion. On behalf of our college, PDA College of Engineering Kalburgi, and our department, ENC, and particularly on my behalf and faculty of our department, I am very thankful to you, Nishant, for joining us on this occasion. In the future also, we will look forward, and
Okay.
once again, I convey my heartful thanks to you and your the teams who are assisting you. Thank you very much, Nisha.
Thank you so much, sir.
Please convey our regards to our Gurudev.
Right, sir. Welcome.
Okay, thank you.
Okay, sir. Thank you, sir. Thank
Now
you.
I request all the participants to join tomorrow at sharp at 10 a.m. and another two eminent personalities are going to deliver the lectures. Now I request all the participants to quit and enjoy the rest of the day. Thank you and have a good day. Thank you, sir.
Thank you, sir.